Hello, welcome to another episode of Sound Talk Show. Today we are going to code Wolfram language, Advent of Code. Get ready for an adventure of programming of the most advanced programming language, totally vastly different from all the others. Different from Rust, C++, C, Java, JavaScript, Python, Ruby, Golang, and different from Haskell, Julia, or Camel, or the functional programming languages. Okay, so let's begin. So my keyboards, I introduced it so many times. Glove 80, fantastic. Ultimate Hacking Keyboard, fantastic. Nulia trackball, fantastic. I have video reviews on each one of them. Just search for it. And this is Svalbard, Svalboard. Svalbard. Search for it, you'll find my videos and other people's websites and information. Cheers, apple juice. Never drink sugared water such as Pepsi and Coke. Okay, let's begin coding. Let's try to not to talk too much and focus on solving this problem. This is advanced code. Potentially, it's gonna be 2 hours. So here is it. This is today's talk show page. So if you can search for xali.info, Advent of Code 2023. We did so many problems in the past, and there's a mistake. You see this list, so let's fix that. So I'm using Emacs Softlight keys, and you got extra UL, so there it is. So we are doing day 13 of Advent of Code 2023. Day 13, okay, so showing browser. Okay, go back, close showing browser. Okay, let's begin. And today's thumbnail image, pretty Chinese girl with a wolf. Wolfram language, that's the reference with the wolf. Generated by AI. 2 videos ago, we talked about artificial intelligence. It's a fascinating thing and a giant stride in progress of technology. Huge. It's just amazing. So, Wolfram, so let's begin. Okay, let's start to read the problem. Hello, if you are here, say hi. It's always nice to see a Wolfram language programming episode. Fantastic. Thank you, Dan. Okay, let's this time, last time, day 12, Advent of Code 2023, day 12, about last month we did. I failed. It took me almost 3 hours, talking about it and didn't have a solution. And we'll go back to it, later. But because that problem, if you just brute force code it, it's gonna be not too interesting. But that problem, the solution is just a math formula. Okay, you just compute a math formula. Okay, so anyway, today, day 13, let's begin. So with your help, the hot springs team something. There's just one problem. You don't see any lava. You do see a lot of ash and ingenious rock. As you move through the valley of mirrors, something. You note down the patterns of ash, represented by a dot, and rocks represented by a pound sign. Okay, you note down the patterns of ash and rocks that you see as you walk. Okay, your puzzle input. Perhaps by carefully analyzing these patterns, you can figure out where the mirrors are. So I've learned, via Advent of Code, you can ignore the blurbs, that comes before. Elves shit. One of the issue in their wording of the creation of the puzzle is that they do not, this story, the background story about elves is not tightly integrated into the puzzle. So you can actually completely ignore whatever the elves say. Just start to read the paragraph before this thing. Okay, so let's copy that. Okay, so let's begin to do it. Okay, so let's go to the bottom. Okay, so section. Okay, so this is some kind of puzzle input, toy input. Okay, actually, Yeah, so there, showing browser. Okay, let's actually do it in front. Doing code, so let's do it at the top. Okay, so there is our toy input. It's just focus toy input. So here's a toy input. To find the reflections in each pattern, you need to find a perfect reflection across either a horizontal line between two rows or across a vertical line between two columns. Okay, in the first pattern, the reflection is across a vertical line between two columns in the first pattern. Okay, so they give two patterns, 1 and 2. So let's magnify more. So the first pattern, let's shrink this. Stupid, I digress a lot. You see, this is a problem of the web design. Their page does not use a flow layout, so if your window is not big enough, they cut off. Idiotic. Okay, so you have to okay, let's focus. So you got this text input, find the reflection. Okay, so in the first okay, so in the first pattern, the reflection is across a vertical line between two columns. Okay, between two columns. Let's see. Okay, so you can see, so apparently you can see a symmetry. So there is a middle line, like somewhere starting there, that reflects the patterns on the left and right, but not necessarily the whole, but there's a symmetry. Okay, so the problem is probably find that line. Okay, in the first pattern, the reflection is across a vertical line between two columns. The arrows on each of the two columns points at the line between the columns. Okay, so 1, 2, 3, 4. Okay, so they showed that. So yeah, okay. So in this pattern, the line of reflection is the vertical line between columns 5 and 6. Because the vertical line is not perfectly in the middle of the pattern, part of the pattern, column 1, has nowhere to reflect onto and can be ignored. Every other column has a reflected column within the pattern and must match exactly. Column 2 matches column 9, and so on. Okay, so the second pattern reflects across a vertical line instead. Okay, so you can see it's between line 4 and 5. Okay, this pattern reflects across the horizontal line between row 4 and 5. Yes, indeed. Let's see. Yes, so 4 and 5, yeah. Row 1 would reflect with a hypothetical row 8, okay, but it's not there. Okay. Okay. To summarize your pattern notes, add up the number of columns to the left of each vertical line of reflections. Add up the number of columns, so it's a sum, incremental sum. You add 1 plus 2 plus 3, something, probably. Add up the number of columns to the left of each vertical line of reflection. To that, also add 100 multiplied by the number of rows above each horizontal line of reflection. Okay, so to that, also add 100 multiplied by the number of rows. The number of rows, not the row number. The number, how many rows above each horizontal line of reflection. Okay. In the above example, the first pattern's vertical line has 5 columns to its left, and the second pattern's horizontal line has 4 rows above it. Okay, so total 405. So wait, how does that? The first pattern has 5 columns to its left. So okay, it's not incremental summation. It's just the number of columns to the left. okay, multiplied by 100 multiplied by number of rows, okay. So you find the vertical, if depends on whether it's vertical symmetry or horizontal. If it's vertical, you count the number of columns to the left. Then so there's a total number of columns, let's say v for vertical. So v is an integer. You count of columns, okay. Then h is the count of columns above the reflection row. So v plus h times 100. Is that what okay, so yeah, but make sure we understand this part, what the answer. Basically the problem is you want to find the mirror column or row number, okay. But let me make sure. Number of columns, okay, to the left of each vertical line of reflection. Add up the number of columns. What does that mean? Add up the number of columns. So in the first example, the number of columns to the left is 5. 1, 2, 3, 4, 5. So, and the second example, the number of rows is 4. Okay, 5 and 4. So first parallel vertical line have 5 columns to its left, and the second, okay, so the second is 4. Oh, fucking stupid phrasing of English, incompetent. You see, it says add up the number of columns to the left. This, I mean, you just say the total count of columns. Okay, wow, the number of columns is a bit, it's not perfect description. So this pertains to technical writing. I wouldn't say this advanced code technical writing is average, not superb. So the basically count of columns, okay, then plus the count of rows times 100. Okay, so get your parser input. Let's get my parser input. Okay, copy, and let's new file, new buffer, and you want to save it as let's say advent of code D13, okay, then text, okay, copy that, close, and link here. That's my input. What? Wait, oh god. So you got a space in file name. You don't want that, so let's fix it. Copy the file path, close, paste, link, make a list, show in browser. There it is. Okay, so let's look at our problem. Let's just have a look. So each block, so you got several kind of blocks. Okay, can we do that? Okay, you got several list of blocks, and let's just show in Emacs. It's easier. So you got several list of blocks. So you first of all split them into the blocks. Then so each one has either vertical symmetry or horizontal symmetry, something like that. So total number of lines 1300. Okay, so let's look at one of them. So you have to determine whether they are vertical symmetry or horizontal. So what is this one? Okay, is it easy to do by visual inspection? Okay, not so easy to do by visual inspection. Interesting problem. So far, I have no idea how to go about. But let's see. Where is the So you want to find the symmetry. Where would that be? So you got this odd thing. Okay, let's focus on horizontal symmetry first. So I mean horizontal reflection symmetry. I don't seem to see it. Now, is there a case when there's no symmetry? That's a tricky part, advent of code tricky shit. They don't say. So if it so happens there's no symmetry, what are you supposed to do? You have to be careful to read the problem again. Find the line of reflection in each of the patterns in your nodes. Okay, so I think it implies there's always a symmetry then. So let's just search. Oh, okay, wait, that occurs there and there, but nowhere else. So what about this part? Doesn't occur anywhere. Let's use Emacs for help. Okay, so this doesn't happen anywhere. This doesn't happen anywhere. This, okay, wait. This doesn't happen anywhere. This doesn't happen. So there's no horizontal symmetry. What about the vertical line? Oh God. So one way, I think the best way to solve the problem is first of all turn it into a matrix. Once in a matrix, you can do transpose because transpose is a standard procedure in linear algebra. So you can transpose. So given a matrix, you want to find the symmetry row or symmetry column. Which one is easier? Going by row first is easier because typically you compare by row. Okay, so once you're done, you try to find the row, then you just flip it. Transpose, then you do it again. So okay, so in this first pattern I don't see a symmetric row. What about vertical line? Is there a mirror line? Oh God, okay, so how am I going to, how do you do this? You see, when you have a row, all you have to do when you are checking out a horizontal mirror line, all you have to do is find the same row. Okay, so you go over, if they must have pairs of rows that are the same. Then if you compare, then you cannot, if the pairs match in a way that they the outer pair match, then inner pair matches, then you got the mirror line. Okay, so if none of the row are same as the other, or if they are only like it's tricky because what if the mirror row is right here? That means there's only one line that's mirrored, you see. So what if, is it possible for the mirror to be, now remember the mirror is between the rows, so yeah, so it's possible the mirror is just above the last row. In that case, you only have one row that is the same. Well, actually, the other row might also be the same as this one, but so this is tricky. How do you identify, so how do you find the mirror row? That's the first problem, okay? So first of all, in order for mirror, in order for a mirror line to exist, that means there is at least one row that's identical. I mean, at least a pair of rows that's identical. For example, at the bottom two, at least. Okay, but that does not imply only, because you could have a line over there that's the same as the one in the bottom. but you know, only these two are the same, you know. So okay, so let's write out the condition, you know. Let's do finding the mirror line first. I like to write out my you know, my documentation, because that gives me clarity, you know. That's just my habit. So the disadvantage is slow, you know, but yeah, anyway. So I don't like those speed coding things. So let's do first find the mirror line horizontal first. Then, so actually turn the text block into a matrix, because then we can use transpose, a standard function in linear algebra. Okay, so that's one thing. Then first find the mirror line horizontal first, because rows are more common to deal with, okay, in a matrix. Okay, in order to have a mirror line, at least two rows must be identical. Okay, that's, you know, at least two rows must be identical. So, but that's not the, but this is not the whole condition. Okay, so what are the other conditions to be sure that there's no mirror line? So at least two rows must be identical, and then the pair of rows, okay, the pair of rows that, so you got several pairs of rows that are identical. Okay, each pair, you know, the row number, okay, for each pair of rows that's identical, you got two numbers of their row number. Okay, they must be such that, you know, for example, row 1, 2, 3, you know, suppose if you have the line between 3 and 4, so row 1 is the same as 6, row 6. Row 2 must be the same as row 5. Row 3 is paired with row 4. You know, so 1, 6, you know, 1, 2, 3, 4, 5, 6. You know, they must paired in a bracketed way. So how do you turn that into mathematics? How do you so the sum that we can we use the sum of the row number must be constant. So for example, let's do one example. 1, 2, 3. Let's say this is a mirror line. 4, 5, 6. Okay, so their sum. Suppose this is a matrix with mirror line. Okay, then the sum of pairs that are the same have constant is constant. Okay, so for example, 1, 6 equals to 7. Okay, something like that. 2, 5, then 3, 4. Okay, I don't know, you know, this works out or not, but I'm just you know, go along thinking. So one way is the sum is the same, but you see, you might have more than 2 rows that's the same. You might have 3 rows that's the same for each of these. So when you have more than 2 rows that's the same, it becomes more computational. Okay, so but okay, we must go through this and finish it. Hi guys, let's not like last time talking for 3 hours and no result. At least if I cannot solve it perfectly, at least we should, you know, just brute force show Wolfram language solution, brute force way. So there's something. Okay, so you know, to determine, you know, finding out if there's a mirror line, that's the first job. You know, once you have algorithm for this, then you can just transpose the matrix and do it the same way. Okay, so so how do you okay, so the pairs of rows that are the same is constant. Okay, now is this always true? Well, is this always true? Let's see. Let's open my text problem. Okay. So pairs, so I just have to think. So pairs. Okay, so another insight. The mirror line, when you have a mirror line, let's say this, okay? Let's say between these two, then their pair numbers are the same. So yeah, this is a great condition. So if 2 rows are the same and have a adjacent row number, it is potentially a mirror line. Okay, that's one significant thing. Yeah, that's all you have to do. You just have to compare adjacent rows. That's right. So this is the more important thing. Okay, so let's put that, because you know, this filter out a lot of other cases. If 2 rows are the same and have adjacent row number and are adjacent, okay. Okay. So if there's no 2 rows that are adjacent and the same, then there's no mirror symmetry. Okay, that's first condition. Once you find a pair adjacent rows that are the same, then what is the possibility? You see, oh God. So what if all the rows are the same? Then you have arbitrary mirror lines. You know, each one of them, you know, all the lines can be a mirror. So this is tricky fuck. Let's write that down too. Another thing. What happens if all rows are the same? Then any row is a mirror line. Okay, so does that actually happen in their problem? You don't know, because the advent of code does not say. Where is my file? So you know, so if that happens, then what are you supposed to do? It doesn't say. Wait, so if that happens, yeah, so if that happens, then yeah, depending on which row you consider to be the mirror, the answer will be different. That's right. So, but the advanced level code doesn't say. So, so if you take extra precaution to find such a case, you're wasting your time. Other people brainless speed coder speeds you. Fuck the advanced level code. Fuck. I despise these, I truly despise them. Because if you are a thinker, you really good, solve this, but your thinking got wasted. The Gordian knot cutter, that's another topic we talked about in our Discord. Okay, so anyway, so find a pair, adjacent pair. Okay, so further, so what happens if so okay, you find, first of all, you find two adjacent pair that's the same. Then what if there are two pairs of them? So you have four, so for example, you can have four rows all adjacent and all the same. Okay, but however, wait, so okay, so the rest will make sure it's the, it's like between, it's in the middle. I would say if all rows are the same, then you choose the one that gives you the highest count. Interesting. I don't know, but yeah, but you have to go with what the problem says. We skipped the elf part. I didn't read, so maybe it has some indication there. Okay, so anyway, okay, I want to let me focus. We are already 30 minutes in. So okay, so we are stuck with this. If two rows are the same and adjacent, it's potentially a mirror line. Okay, what are the other conditions? What about four of them are adjacent, then and the same? What do you do? So if four of them are adjacent, but something outside of it can fuck it up. So this is a minimal condition. Two rows are adjacent. So let's go condition one by one. So if there's only one pair of two rows adjacent, okay, then it's easy. You just compare the next one, the outer rows. If they are all the same, keep comparing the outer ones until no rows are all the same. Then you got the answer, whether it's that symmetric line or it's not. Okay, so you see, okay, so first find if there are two adjacent rows. If not, it does not have mirror line. Okay, period. If it does have two adjacent rows, compare their outer rows are the same. If so, continue to compare outer rows till no rows. Okay. When anytime the outer rows no match, not same, the initial adjacent rows is not a mirror line. Okay, we kind of have a we kind of have a sub algorithm. Okay, sub algorithm, let's put it here. If all outer rows checks out, outer row pairs match, then the initial adjacent rows is the mirror line. Okay, now let's check this sub algorithm. So first of all, find okay, we are starting to get into the algorithm of these. Okay, first find if there are two adjacent rows. And same. If not, it does not have mirror line. Okay, if it does have two adjacent same rows, compare their outer rows are the same. Okay, if so, continue to compare outer rows until no rows. When anytime the outer rows not the same, the initial adjacent rows is not a mirror line. That's right. If all outer rows pairs match, then the initial adjacent rows is the mirror line. Okay, that's complete. That's one algorithm subpart. Okay. So, but is this total? Does this fully determine the matrix has a mirror line? Yes. Oh no, wait. Okay, so if the above fails, find the next adjacent same row, adjacent rows that are same. Okay, repeat. Okay, that's the full algorithm. This is a full algorithm to determine there's a mirror line for the matrix. Okay, fantastic. Okay, so yeah, then okay, then we know. Now, is it possible? So we know whether this matrix has a mirror line, horizontal line. Okay. Now, if it does, then good. We kind of find an answer. But if it does not, we transpose the matrix to the same to find the vertical line. So this mirror line is ambiguous. We need to say horizontal. Is that spelled correctly? I don't know. Yep. So yeah, so if there's no mirror horizontal line, you transpose it, then you do the same to find vertical. Now, what if there's no mirror lines at all? Then according to this problem, you see, find the line of reflection in each of the patterns in your nodes. What number do you get summarizing all your nodes? So if there is none, then still works. So if it's none, it's 0, 0, 0, just that block is just 0. Okay? Now, what if there's a mirror line, horizontal line, but there's also a vertical mirror line. So crazy situations. Okay, let's fully document, my style to fully analyze the problem. What if all rows are the same, or all columns? Okay, that's one issue. Now, what if there are both horizontal and vertical mirror lines? Okay, that's another question. And another situation is, what if no mirror lines at all? In this case, the block is 0. Okay, but the first two cases we don't know. I mean, the problem doesn't say. Okay, let's begin to code. Okay, let's begin to code instead of So let's begin to code. Let's see, where do we start to code? Okay, that's analysis of the problem. Let's say code. Okay, so we're starting to code. Let's get the toy problem input. So this toy problem input. Okay. So first of all, you need to pass this input. So input equals to, let's just quickly pass it. So you want to pass by 2 line breaks. Okay. Pass input x input 1, okay, equals to string split. Okay, split input by 2 line breaks. Okay, and yeah, and then you got blocks. Okay, text blocks. Okay. Okay, so for each text block, you want to, let's say, for each text block, you want to turn it into a matrix. Now, I forgot, how do you turn into a matrix? Well, okay, so let's matrix 1, let's say, just for example. So you got the first text block, that's part 1. Then what you do to it, you split string again. Okay, you split string on the first text block, which is this, and then you split string this time by a line number. Now remember, yeah, okay, so yeah, so that can work. So you want to split by a line return character. Then you got bunch of rows. Okay, then you got bunch of rows of string. Then you need to turn it into a list of characters. Okay, let's see if there's a function. Let's look up the documentation for the function character, turn the JavaScript on. Okay, characters represent a single character. Okay, that's not what we want. Let's say characters. Okay, characters given a string gives a list of characters in string. That's what we want. Okay, so you want to map the characters function map. Okay, so you want to map the characters function by, okay, so let's say this is a matrix 1. Okay, you want to map it to matrix 1. Okay, then you got actual matrix. So actually let's put this here. There. This is the actual matrix. Let's try it. So let's run it in Wolfram notebook. Start. So the result, matrix 1, is the first part of the text block, and it is a matrix. Okay, and each element in the matrix is a character, a single character. Okay, let's say 3, shift enter to evaluate it and magnify. Okay, let's put this here. Let's lower this level. So yeah, okay, so Wolfram language 3. So let's copy that, paste it, run it. Okay, then what is matrix 1? Okay, run it. Fantastic. Okay, that's what we want. Now we don't want matrix 1 because actually this is just showing you how it works, because we have several of them. You know, the input has, you know, so many of them. So this is just an example. So instead we want to map it to we want matrices. Okay, let's just say X matrix list. Okay, each one is a matrix. So so this is how you get one of them, and you want to map again. You want to map to text blocks. That's what you want to map to. Okay, you know, not extract it manually like we are doing there. So you want to, but how do you map? Okay, so you want to map a function, of course. So here we need to write a function. Okay, function. Okay, function variable x. Okay, so each one, so the x, each x is a text block. Okay, so the expression is going to be something like that. Okay, so this is x. Okay, that's it. We don't want the semicolon there. So map a function of x to text blocks. Text block is a list of text, like one of them, each item is a block of text. Okay, then for each text block you split them by line, then you map characters to that line to get all characters. Okay, so this is a matrix list. Okay, so let's run it. Yeah, so you got 2 matrices. Okay, so next hippiness. How am I doing? Dan says if they are both horizontal and vertical mirror lines, should you have to analyze them both independently. I'm not sure what you mean, but I mean, oh, you mean if there's one shot solution that you identify both horizontal and mirror? Yeah, you can do that, but that's another different algorithm. You know, if your goal, if the problem is changed such that there is always a center of mirror lines, you know, both horizontal exist, both horizontal and vertical exist, there's always a point, then if that's the case, then you use the algorithm to do that, a more efficient one. But right now the problem is just focused on, you know, either or, so let's not focus on that. So anyway, so we got this. So now let's continue to we want to check, given a matrix, does it have horizontal mirror? Horizontal mirror line, okay? That's the next thing we are doing. So a matrix, we can test it out with the first matrix. So the first matrix has a horizontal, you know, this. So let's go back to our algorithm. We were saying, so basically here is the algorithm, okay? Yeah, let's find if there are two adjacent rows are the same. If not, it does not have horizontal. So find two. So first of all, find two adjacent rows are the same. Let's comment it out. I mean, let's have profuse commentary so you guys can see what I'm doing. So the first problem, how do you find there are two adjacent rows are the same? Okay. Very easy, okay? So what do you do? So this is about Wolfram language, kind of special to Wolfram language. In other languages, you basically start a loop. You know, you write a loop. You know, like, you know, X, you know, for each row, you compare. So current row equals to, you know, the current n. You know, I you know, loop for I to length of the row number. You know, then you see I plus the next loop I plus 1 to see if row I is same as I plus 1. You do a loop. But in Wolfram language, you do partition, okay? So partition, two arguments. The first argument is the matrix, okay? Let's say first, okay, let's say, okay, let's just say this is temporary to illustrate. This is the first matrix. Okay, so you give the first matrix, then you, so you give first matrix. A matrix is a list of rows. Each item is a row. Okay, so you partition it so that you partition it and you want to have repetition of one item. So let me show you what that do exactly. Okay, let's say 1, 2, 3, 4. Okay, so you can see 1, 2, 3, 4. Let's say 5, 6, 7. Okay, so you this visual example is much easier to understand. So you see it generates this 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7. It partitions so that each result is a pair, you know, a group adjacent things, but with a overlap of one item. So that's what you got. If you don't do the if you don't want the overlap, then you just get 1 2 3 4 5 6, right? Okay, so we are doing the partition to this. Then once we got pairs, then we can just map a function to compare if they are the same. Okay, so partition. So let's do it here. So let's see. We need to use random numbers. Okay, let's say 667. Okay, then once you then you map. Okay, you map a function to this partition. Okay, so first of all, you need a function there. So and the function will be just same q. Okay, same q means equality. Q means question. Any function that ends in capital Q in Wolfram language means that function always return either true or false, always. So you just map this same Q to that. Since same Q is a function name, you don't need that part. So for example, I'll show you here. Wait. What? Alright, so let's see. One, two, two, three. So then you map same Q. Why? What happened there? That's not true. What's going on? One and two are not the same. So why is it return true? So wait. So you got that 1 2 2 3. What? God. Wait. Why is it true? 1 2 2 3. None of these are true. So why is it? Okay, so I don't know what's going on. I think there's something wrong. So let me just do this. Okay, for example, 1 2 and 2 3 eval the current line false, right? So what it is? Wait. Okay, so let's try that. Eval the current line true. Okay, so the problem is when you use same and you just have one argument, it just returns true. Yeah, silly. So what we do? Yeah. So we actually want you want to apply. Okay, so basically. A little bit Wolfram syntactical trickery, okay? You don't know what I'm doing, but this will work, okay? Let me just show it. You see, false, true, false. Why is it true? Because you got 6 and 6. So in other words, you want to map a function to these pairs, but you don't want to just pass the whole thing as a single function. You want the function to, you want the list items to become arguments for the function. So basically, so that means you say apply. So a more understandable way to write this part is just apply. Let's do that, okay? Apply same Q with a X, okay? So let me just do that in fact this will be a function of x and there. Okay, so that is much easier to understand. Okay, so for example, copy that, paste here, there it is. Okay, okay, so let's see. So that means the first matrix in our Tory example, the line number. So how do you get this line number? So you see this 1, 2, 3. So if these 1, 2, 3 are row numbers, right? They are row numbers. So they are one less. Okay. So 1, 2, 3, 4, 5. The fifth item is true. So what does that mean? So 1, 2, 3, 4, 5. So that means fifth and sixth rows are the same. So if nth item is true, that means nth and n plus 1th row are the same. Okay. Yeah. Okay. Very simple. Okay. So let's apply to the matrix. So if we apply to the matrix, it should return 1, 2, 3, 4. It should return 3. Okay. We need to find the true position. Okay. Let me show you. Position, do that, and let's say the above. Okay. Then you want to find the pattern for true. Okay, you want to find a pattern that is true. Okay, let's look up documentation for position. I believe that's, yeah, you see position takes a pattern, second argument. Okay, so there it will return 1, 2, 3, 4, 5. Okay, it will return 5. That means wait, control what, shift enter. Okay, so you need shift enter, 5. You see, so that tells you the fifth and sixth row are the same. Fantastic. Now it may return multiple results when there are more adjacent pairs are the same. Okay, so far, so you see we are not doing any loop. This is supreme functional programming. Supreme. In other languages, you don't do this. Rarely, actually, they don't even have partition. I think Python just added that a few years ago. But I don't think they even have. I mean, in our case, we need partition with the overlap of 1. I don't remember if the Python functional library have that. I do think that they added partition. Anyway, so let's remove that more hard to understand version. So put it here so I can write notes later. So this is what we want. So this returns a bunch of true and false. Okay, so actually we can run it. Okay, so actually let's do this. Okay, so we didn't. So it returns that. Okay. Then you just need to use the position. Okay, let's see. Let's just say these temp variables. Okay. so now you just say x3, so that returns if it's empty means no same adjacent rows, else result is a index int, or meaning result is a list of integers, each means the let's say the result is say for n means nth and n plus 1 rows are the same, okay? Okay, so something, okay? So now we identified, so if there is, we need to string all these together into one block of code. So if there is no such index, then there is no mirror rows at all. Okay, we determined. Then if there's if there is, then we need to then we need to then start to compare outer rows. Yeah. Oh God, tedious shit. Now I'm kind of I want to stop. Yes, you have to give two arguments to same queue. So Dan, are you a Wolfram language coder? Looks like you are. Did you buy the Wolfram language, or are you using the Wolfram script? So anyway, so so then yeah, we made some progress. The next thing is to compare okay, then we compare their outer rows. Oh God. This can also be easily done. You have a list of rows. Once you find a pair of adjacent row, you split this matrix by that, you split the rows above and the rows below. Okay, so you got two submatrix. Then you just then you just flip the first one, like reverse order. Okay, so their row are reversed. Then you just compare the two submatrix row by row to see they are all the same until one of them run out. Okay, run out of rows. Yeah, so God, more coding. Yeah, okay, so we need to start to have some sensible variable names. Okay, so first matrix partition. What is this? This is actually just an example. Yeah. Okay. Example of partition. So that's actually not a problem. Okay. Yeah, so I mean, let's just show it. Okay, so the same, this will, run it, eval by line, this returns false, of course, and if only one argument, it returns true, which is a mistake. Okay, so but what we want to do is actually this. Okay, so this is syntax shortcut example. Okay, the Wolfram language, that's a whole chapter about it, very interesting. You see, because in Wolfram language you can turn this, when you paste this, you press the key Shift Control N, it will turn this syntax into well, not exactly like that, but I mean, well, let me show you. Control Shift N, okay, it turns into that, but you can turn that into this syntax by just saying this. Okay, hold full form. Okay, Shift Enter, there it is. So you see, you see, so they are like syntactically equivalent 100% at the because the Wolfram language, even if you do 3 plus 5, before it computes that, it turns that into the full form syntax. It turns that into plus 3 5, so it basically turns that into a Lisp syntax before it does anything. But it offers you this kind of syntactical shortcuts like that and like that. So this, in Lisp you would call that reader macro. Okay, so again, Wolfram language is like, it's a Lisp. So anyway, so we are digressing here. So but let's go back to our problem. We want to actually solve the problem. Okay, so the first matrix is that then you partition. Okay, so you don't need the variable there, so you put that here. Yeah, so that's the actual matrix you want to partition. Then you apply the function, then you need to say position. Okay, position, you want to find the pattern that is true, so put this part into the first argument. Okay, so this will return all raw numbers, return all raw numbers of the first row that are adjacent and same. Okay, that's what this does. Is of int, each is a raw number, means it and next row are the same. Okay, better technical writing. This is the art of technical writing. Return a list of integers, each is a row number, means it and next row are the same. So if empty, then no same adjacent rows. Okay, now but if it's not empty, so now we can properly name this same crazy long file names which I usually do. Same neighbor row index list. Okay, something like that. Okay, getting crazy. So now, but anyway, we have nice variable, and very short. So you see, the whole solution to this problem is one single line. Like every of these advent of code, their Wolfram language solution is one single lines of code, no more than 200 characters, at most 300 characters. Okay, so anyway, same number. Okay, so what you're gonna do with this? So if it's empty, there's no there's no horizontal mirror line. But if it's not empty, then you need to go through each one of them. Fucking tedious. Then it's a fucking tedious. Then you need to split. Then you need to. Yeah, God. Oh, you got a copy of Mathematica 13. Fantastic. Yeah, fantastic. Yeah. Functional programming, no loops. God, I want to stop, because it's, how long have it been now? It's 70 minutes now. Yeah. Shit. Pain. Repetitive strain injury. Typing too much in the past month. Right here. So we have these special marble balls prepared. So I can do this. Feels comfortable. These are kind of heavy. This is a crystal ball. Fantastic. Oh, this is ray tracing, physics. Like Stephen Wolfram's cellular automata, computational universe. You see, at this moment there are billions busy computation going on there, so that they can show your face. You see, any moment, all the atoms, light rays, neutrons. They are busy calculating which one, where should I be. They are also busy. So this is Stephen Wolfram's science of cellular automata. And okay, a break. Okay, so do I need to push through? Yeah, I will sure find a solution today, but maybe I a break or something. God, so let's see. Do I got any? Okay. Who else is watching? Is it fun? So let's see. 3 concurrent users. Thank you, Dan. Dan, you are the only one watching. Okay, so this yeah, we need to finish it. Where's Steve? Steve is actually watching in the background. Take a 10 minutes break. Okay. Yeah, actually that's a good idea. So yeah, that's a good idea. So let's be back in 5 minutes, okay? So let's clean up a little bit so that so we got, let's okay, so that's our code. Basically shrink a little bit. Wait, yeah, that's our whole code. Okay, so can you guys see it? Yeah, so I'll be back in 5 minutes. Drink and smoke. Smoke got into my eyes. Okay. So, yeah. Okay, let's begin. Let's continue. I'm back. Welcome back. So first, let's say first row indexes. Let's say first. So are these still the same matrix? Yeah, we are working on just the first matrix. So first matrix, same neighbor row index. Massive long list. Okay, so yeah, the first one is just that. Okay, then then you do something to that. So fuck. You see, it returns. Let me show what it returns. Okay, let's select all. Go here, paste it, evaluate it, then x same neighbor show what's the value. Okay, there's a number. Now what if it's all empty? So yeah, you see the problem right now, if you want to say, if what do you want to say, what you want to check if it is empty list, but the list may be nested empty list. You see, so first of all you want to check if it's nested list but it's all empty. So there are many ways to do that. So for example, I can I can focus on solving a problem, but or usually I distract and do the easy problem. Easy problem is just showing toy examples of how to code Wolfram language. So for example, if you got this list, you want to determine if you have this list, you want to determine if it's all empty. Okay, what do you do? So that's what we need to do. If this or this index is empty. Wait, so okay, actually that's not the case. So the possible case is actually just either that or not that. Okay, so let's forget about this. The actual case is either that or like a list of numbers, like that. Okay, so these are the two possibilities. Let's write it out. Two possible results. This or something like that. Okay, let's put that here. That's what this is. Okay, so to determine that is easy. So to determine that is just that. Okay, so if this is true, that means there's no horizontal mirror line. By the way, same Q can be rewritten with triple equal. So another easy Wolfram language tip. This line and this line are exactly the same. They, before Wolfram compiler do anything, they first turn this syntax like this into that. In fact, this is still not full form. In fact, it turns it into this. Okay. So it turns that into this. They are the same thing. Now, why is this? This is actually very important, the full form syntax or Lisp syntax, because when you started to do pattern matching, it's matched against the full form. Okay, so anyway, let's put the tips here. It's something we explained about the tips. Syntax shortcuts and full form is called full form. ARCA. Syntax shortcuts ARCA, Lisp reader Marquardt, and full form ARCA, SIXP in Lisp jargon, the Lisp phonetics. Okay. Do I make sense? Then do you code Lisp? So anyway, so we want to same. So we if this is true, then basically it means no horizontal mirror. Oh God, this is otherwise. Okay, something. Oh God, there's a lot to code. Shit. Yeah. So basically, if it's empty, then stop. But if it's not, then we need to do something. We need to, for each of these number, there may be multiple. For each one of them, you want to split it by that row. Yeah, God. Okay, how do you split the list? Let's just start to code. Okay, so is there a split list? Spelling corrections. So I don't know. It's we need to look up. So you need to do this here. So show all function names that contains the word split. Okay. So basically, we want to split a list. Audio split by, string split, file name split. Okay, let's want to see what is split. Split a list into sublist considering of runs of identical elements. Oh, this fantastic. You see, we don't even need to do consisting of runs of identical elements. Yeah, we don't, we actually can skip this partition thing. This directly split. Okay. Exactly, split into run of identical elements. Yeah, so actually we can skip this step. Yeah, so you have a bunch of rows. You're split at any two adjacent row numbers. So if there is no okay, so that's one thing. What's split by? Split into list of sublists consisting of run of successive elements that gives the same value when f is applied. And we just need split. Okay, let's go here. That's another excursion. Split. Okay, let's say 3, 3, 4, 5, 6. That's easy. Okay. oh, okay, it just it returns that. So nah, that's not what we want. What about options? There's probably options. Yeah, basically it's doing what we are doing. Split can be used to perform run length encoding, okay? It can be used to do run length encoding. Okay, for example, increasing runs of it. Okay, oh, you can do less. So if that function applies, yeah, God. Okay, I really need to focus on solving a problem, okay? Because otherwise it's gonna take another 2 hours. So let's just continue. So split. So we got a bunch of rows. We want to split on adjacent. So if we do this split, then we got things like that. Yeah, so we got kind of a pair. Each result. So if the result has length 2, that means that's it. So the result, each element in the result will either be length 2 or length 1. Is that true? I think so, because you can do, for example, now remember our case, each item is actually a matrix. So for example, God. So our example is actually, each item is actually a matrix. So something like that, okay? So you see, this is a matrix. Now, if 2 of the items are the same, let's say you see adjacent rows, so what do you get? Okay, so it's starting to get complex. You get that 3, 3, 4, you see, right? So that's still correct. So each item in the split result is either length 1, like that, length 1, or length 1, or length 2. So length 2 is where this adjacent row, but the rest of rows, they become an item of themselves. So, but that, okay, that's not how you want to split it. Oh, okay, let's do a reverse, unsame. Okay, so you see, let's do so unsame q is basically not same. So the not function, reverse of same, okay? So if you say unsame q, then you get, let's do it here, okay? So first of all, if you run that, you get that, okay? Now if you run this, you will, that's, I think the result is what we want. Let's do it. Okay, let's see. It returns that. Now, yes, that's what we want. You see, this is one group, exactly. So a matrix of rows, it's split at, they split it into 2. But what if we have, yeah, so you see, what if we have more, God, what if we have, let's say, x, y, so another same pair there, and then let's just say random, okay? God. So you got that, so these two the same, these two the same. What do you, oh God, we forgot to save it, okay. Anyway, so let's do it. Okay, comma encountered, okay, so extra comma, you don't want that. Well, you're missing a comma here, okay. So let's check, okay, run again. So you got this result. How do you, so again, so now it's split into 3 groups, okay. So you can see 4545 there and xy there, right? So now, but actually we just want the first, you see, because we want to do it one thing at a time, the first pair of the same rows, adjacent rows at a time, then do the next. So if there is another optional argument that says return the first n, no, I don't think so. So okay, this is not good, this is going too slow, okay. By this way we will never finish. This is too slow, okay. So yeah, let's just focus. So you let's just do, now we need to a function that's split by position. You can, range 9, okay. So let's say range 9, let's say 6, okay. 1 2 5 6, that's correct. And let's say drop 7 8 9, yeah. So this is how we can do split, okay. Each of this number is that index number where the row is the same, okay. So we can, this is split by position, okay. So once we split the second part, we the first group, reverse the order, then compare each. Yeah, God, there's so much more coding. So so it's matrix row indexes, okay. So let's see so far. Copy, close that. Let's see what this x first, okay. So it gives you an index, let's shorten it, okay. It's just, okay, much easier, shorter. So first name, so this first same, the first same index, so if the first same index is that, then no horizontal mirror. Otherwise you need to split it. Okay, God. Let's put that there. This is our like scratch pad. So paste it there. So if the first same, delete that. So then you got split by you basically you want to split by a matrix. I mean this matrix. Okay, so that's the above row and bottom row, and so you want to split on what is this x first same. Okay, so and this will be the index. So this will be the index, something like x. So we need to write a function. Okay, so the function will take argument of x and it will return this, which is split. Okay, now for the second part, for the first part we need to reverse. Okay, reverse the order. Okay, check the documentation, reverse at least. Yeah. Okay, so you want to reverse then you want to compare. Oh God. You can do partition again. So I don't know, you guys know. If you have questions, ask. Okay, so so we apply the function reverse, and we want to compare each pair. Let's say 1, 2, 3. So 1, 2, 3, and yeah, let's say the second part has more numbers. You want to check them so that this will be considered equal. Okay, so map thread. What do you get if you do map thread? Okay. Yeah, the length are not the same. Then you need to shorten the length. Shit. You don't want to do, there's more tedious coding. So let me think if there's more elegant solution. Now this is getting too complicated. So you have adjacent same row number. Somehow is there a function that does symmetry, matrix symmetry? Okay, like we want to know if there's a function that automatically can determine if there's like row symmetry. Okay, so let's do this again. Yeah, it's not. Yeah. Why is this? Stupid. How can it possibly? Can you just run? No, it's like 3 rows. Okay. So argument symmetry, persistent symmetry. Okay, so not symbols. S Y M M. Okay, 2M. Shift return. Okay, symmetric matrix. Okay, now that so yeah, so that is not what we want, because symmetric matrix to a structured array. Okay, so symmetric matrix that usually is like diagonal symmetry. Symmetric matrix is when represented as a structured array, allow for a convenient specification. So yeah, this symmetric means they are symmetric along diagonal axis. So that's not what we want. We want Hermitian matrix. What is Hermitian? Converts a Hermitian matrix into a structured array. So, so what is a Hermitian matrix? Okay, the Hermitian matrix is a matrix, symmetric matrix, but plus something else. Let's see. Hermitian matrix, also known as self-joint. Okay, works for symbolics. Okay, so a matrix M is Hermitian if M equals to conjugate transpose. Okay. Yeah, so that's still basically symmetry along a diagonal axis. So, but in linear algebra, yeah, you don't really have the concept of like the symmetry of rows. So what is there some kind of, so yeah, too slow. So do we really need to do this manually? Yeah, but if you do it manually, you got just small codes to, the worst is like the bunch of if statements, like that's what C coders would have to do. They have no other choice. For example, we want to compare two matrices if they are the same row by row, but however one of the matrix may have less number of rows, right? So of course in C you just do a loop. You check, each one you have the length, the short. First of all you have to find the minimum, which one is the minimum length, then you go from 1 to up to that length, then you compare each row, you extract the matrix and so on, right? That's a typical iteration, the imperative style, procedural style of loop. In C, that's the only choice. You have no other choice, But in Wolfram language, that's how you do it. You can use this map thread, but that's not, but then we have to drop, this part. That's not what we want. So let me just think about. Yeah, so only tricky to, this type of problems can be really tricky to program using only functional and pattern matching. Yeah, well, functional and pattern matching, it just require more thought. Actually, pattern matching, so let me think about that. Is there an easy way? Yeah, maybe there's one-shot solution to the whole thing. Pattern matching, okay? So pattern matching, let's see. That's the potential. One single line pattern matching will find the, yeah, exactly. So let me think about pattern matching. So pattern matching, you have, so you want to match a pattern, so such that the top list of rows is like reversed from the bottom list of rows. Okay, so and you know, the number of rows may not be the same. You know, you might have yeah, so but it's possible. So let's see, pattern matching, you want to have a list of rows. Yeah, actually it's very possible to do this whole thing in pattern matching. Okay, so let me, you know, I don't know, you know, I can either match Q expression form. Okay, so yeah, we can use that to, yeah, expression form. So what level does it match? The levels, the whole expression. Yeah, so string match member free Q replace pattern. Okay, so we can do that, but how do you specify? So the, if you use pattern matching, the issue is how do you specify the pattern so that it fits the problem, you know, find the symmetric row number. Yeah, that's actually very possible, but you so you know, I can show you an example. For example, so for example, you need a matrix, you need a matrix somewhere. So matrix list, same index list, first matrix. So let's get the first matrix. Okay, so that's your first matrix. So for example, that's what it looks like. Oh God. Oh God, this, why is it? Yeah, so that's our first matrix. Yeah, so then you, what you do is that, for example, this first matrix, you, yeah, we can use, you know, so the first matrix, yeah, so there's a horizontal line, then you can, so so you put the first matrix here, and you want to specify a pattern that matches that. How that's the gist of the question. How do you, is it possible? So the pattern to find the horizontal line is that you have two, first of all, you have two shapes of matrices. So one or more. So this is a sequence of things, one or more, and okay, so this part basically means one row. Okay, two means one or more. Okay, so this, so the first, you know, this part means a row, and adding that means many rows. So you want to give a name to this pattern. So let's say rows. Okay, so rows is a name for whatever matched pattern that you can give a parenthesis. Okay, but then you want to say that this, God, so then you need another you know, then you need rest rows. Okay, let's also give a name. rest rows. Okay, so so the rows are split into two patterns. Okay, then you need to say, you need to add a condition for these to match, and the condition is that, so this is a syntax for condition. The conditions is that, you know, we are back to what we were trying to do there. You have to use some kind of function to do it, or can you purely do it by pattern? Now if you want to do it purely by pattern, then you need to give each row a name. Yeah, so this is not, this is okay, let's go to patterns. Okay, pattern matching. So here's the introduction to pattern matching, what exactly it does. Pattern matching syntax, I updated these pages last week or so. So blank, so you want, close that, you want to be able to find the symmetry. So yeah, so basic named patterns, then repetition 1 or more, or 0 or more. Then you have repeated patterns, right? Yeah, and then you have conditional pattern. Yeah, so this is what you have to do. Condition, I need more example here. I forgot which one is which, condition or pattern test, but anyway, one of them. Okay, so let's check. So let's check. So condition, let's see example. So condition is using a expression. Okay. Okay, now I got it. So now pattern test is using a function. Okay, so pattern matching can be supplemented by a condition clause. You have two ways. One is pattern test, which given a pattern, when it matches, you got, you know, you name it, such as here row and rest rows. Then you can apply a function to your named thing to see if they are true. If this function return true, then the pattern is considered matched. Okay, so that's supplemental with a function to test pattern. The other thing is this condition, which instead of using a function is simply use an expression. Okay, but basically they are the same semantics. I mean, they are the same thing. One is just using a function form, one is just using expression. So okay, we got that part clear. So but here we, so you know, either case, so we want to basically, we want to compare the rows and rest rows such that the reverse of rows is the same as rest rows, item for item. So we need to write a function here. Now, but one of the problem is that the rows and rest rows may not have the same number of items. So that really, yeah, so that, you know, like ultimately you do need to write this code. But suppose we do that, suppose we do have this, I mean, it's easy, it's not hard to write this code. You know, you just have to, it's more tedious. You just have to find the shortest of the two and drop the, you know, extra rows. So if we do have that function, then this pattern matching, then we don't have to do all this manual thing before, because this pattern matching can actually, I believe so. Okay, I don't know, but so okay, let's focus, let's write this function. How do you So let's see. So so rows, a bunch of rows, and so first sequence of rows and rest sequence of rows. Then you need to okay, and let's look at map thread. So if is there a way to automatically drop when their length are not equal? So let's see, threaded inner transpose through. That's no co-map. That's experimental. That's not what we want. Okay, let's see, through. Through is more complicated. Through is hard to understand. Yeah, that's nested function application. So we want something like a map. So we actually, once, like, if you work out at the end, it's really simple, just like 2 or 3 lines for the whole problem. But the problem is just figure out what thread. Thread is another complicated thing. Threads f over any list that appears in args. Okay, thread ABC. So what? AXBY. Yeah, that's not what you want. So you see, you can do it by hard coding it, but I'm trying to find a simple way of dropping the last elements, dropping the extra elements, but we need to actually solve the problem. Okay, drop. So you got two bunch of rows, two lists of rows. You want to drop the one that has extra length. Okay, so yeah, gotta take drop. Yeah, we can do this. So I mean, so we can like do transpose and partition. Yeah, transpose and partition. Then you just map same. Yeah, but it gets more complicated. So you can just or you can pad the smaller one. So there is, you can pad matrix actually. Array pad, that's what we want. Array pad. Okay, so array pad, you can, okay, I need to. Okay, this is taking too long. That's no good. Concurrent viewers 4. Okay, so function reverse, yeah, that splits the matrix into 2 sub-matrices. So once you have split, then you use some kind of, so I need to cut off the one that's longer. Yeah, definitely cut out the one that's longer. But I don't want to do manual, find which one length, get the length of both and compare which one is the minimal, then drop the other, create a new, new list of rows, drop in the extra line. I don't want to do it manually. There is absolutely a simple way, okay? So it's just about thinking about it. So we got you got 2 lists, so you want just to drop. So there's some kind of same map. So if you have so the length are not the same. How do you do that? So shit, God, I stuck on this pure ideological problem. Okay, that's the problem. Given 2 lists inside the list, create a list like this, namely drop the longer list rest items. So what is the proper, what is the the precise way to do this? And can we do pattern matching? Okay, so back to pattern matching, we can reverse rows. I am not doing a good job now. So okay, so if we focus on this sub problem, pure problem, how do you do that? So so array pad, yeah, you can use array pad. If you use array pad, you have to find out the dimension of one of them, which is then like manual coding, because you need to find how many you want to pad. but I'm so why is the map thread? I want something like map thread, but ignore extras. So let's think about this. So yeah, we want to map thread. We threaded in a applying function to part of expressions, applying function to a list manipulation. Let's see. Table, array, range, subdivide. No. Sparse array, numeric array. No. Tuples. No. Nest list. No. So list, subtraction, first, last, take, drop, take, list, extract, append, replace parts. So drop can be used, but then again you need an explicit number of items to drop. But I don't want to manually, to get that information. So select and cases select. So is there a way, or am I just stuck in pure fantasy land, like academic fantasy land? I'm pretty sure there's a way. Splice, okay, no, that's splice, no. So flatten. Okay, so these are kind of what we want, okay. Rifle, okay, rifle. Rifle is basically interweaving two lists, okay. So you can see in this example, it interweaves two lists. Now, what if one of them is shorter? That is the question. There it is, rifle. Okay, so rifle, let's say it takes one argument or two, so it can take, two arguments, okay? So back here, remove the bigger one, do it. Okay, 1122 and 1122 and 3, it dropped at 3. Why does it drop at 3? I don't know, but rifle is probably the answer. Okay, let's reverse the order. Let's see what happens. Okay, evaluate it. Okay, so 112233 4. Now this should return 3 3, but it just got one single 3. Why is that? Yields a list in which every nth element is x. Okay, that's interweaving things. That's what rifle is. Because once if this returns 1 1 2 2 3 3, then we can just partition it. Then that solves our problem. Partition into 2, every groups of 2. So so we're getting closer. Okay, not yet. Now we want to find out why is this rifle. It should be 1 1 2 2 3 3. Why is it 1 1 2 2, take one from each, and 3. Okay, so why is it stopped short there? If there are fewer xi than gaps between e in rifle, the xi are used cyclically. Okay, the order matters, the order of the argument. The x1 is used cyclically. Okay, 1 1 2 2 3. So you want to put the longer list in front. Okay, so you can, one way to do that to solve our problem is you put the longer list in front. Then you do the rifle. Then you just partition it into groups of 2. When you do partition, it will automatically drop the indivisible rest of items. So when you partition into groups of 2, if you have odd number of items, the last one is dropped, which is what we want. So, but what if the first one is significantly longer? Let's try. Okay, 1, 2, 3, 4, 5, 6. Okay, run it. So you got 1, 1, 2, 2, 3, 3. Then okay, then it uses the second argument to interweave cyclically. So 1, 1, 2, 2, 3, 3, then 4, 1, 5, 2, and 6, 6. Okay, so you see the rifle doesn't. You see, rifle interweave things in between, so it doesn't. That's why it doesn't have the last part. But we want the last item. There's a way to do that. So yields a list in which every nth element. Okay, so you want to rifle, but you want the last. Yeah, you can do that, but then it gets more complicated. So oh shit. And let's just say it's getting too complicated. What's delimited sequence? Represents a delimited sequence of elements of the specified form in interpreter and related functions. What does that mean? Yeah, I don't know. Go back. So let's just use pad. Then you just have to get the length. Yeah, you just get the length of these 2 lists, then just drop one of them. So finally, you have to use. I mean, you have to call length. So pad left, we want to pad right. Yeah, we want to pad right. So pad right. Pad right, just add extra items. So this is actually the easiest. But if you use pad right, you still have to get the length. Okay, what? Pad. What? Yeah, then you still have to get the length. Victor, hello. Pad right. So okay, you think too much, so let's just code it. So if this is a function that drops reverse and then okay, so pattern matching solution. Now when you use a condition, what's fed to the function? Pattern test. Oh, okay, so when you use a function, you can only check the whole matched pattern. That's the argument passed to the function, okay? So you cannot use, in our case, you cannot use the pattern test. You need to use the condition. Yeah. Yep. So yeah, that's right. So that's why you have to use this condition. The condition is that the first rows is reverse of first rows is the same as rest rows. Yeah, we can do that. Okay, so let's see. The condition would be, let's say parentheses, reverse first rows, okay, reverse the rows. And so yeah, we need another pattern here. So reverse of the first bunch of rows. So we need another match queue. Okay, another condition, nested pattern matching. So this reverse of rows matches okay, so reverse of rows, yeah, but then we make sure we still need to know which one's got more rows. So reverse rows let me just do this, okay. We need splice. Then one or more, so 0 or more matches rest rows, okay. So condition is that or this is really getting complicated, or we reverse these two, okay, that way we don't have to find out which one is more items. Yeah, I'm not sure this will work, but we can try. So let's see. The syntax is correct. So yeah, so let's try it. Now this is purely advanced test. Now, if this returns true, that means we have one single line to find out a matrix has a row mirror line, horizontal. Okay, run it. Okay, syntax error. God. Expression cannot begin with dot 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 dot. Oh, what? Oh, because yeah. So this should be blank blank, one item or more. So wait, yeah, one item or more, blank blank. Okay, so do it. False, which is not correct because our matrix is symmetric. There is a, these two lines, horizontal mirror line. So this is false, obviously, because we need to refine it. Yeah, we can do this in pattern matching for sure, but it's just that. Now, what is the alternative? I forgot what is the alternative, but let's just forget about that. Okay, let's see. Yeah, these two lines. So the first group got 3 rows. The second, 1, 2, 3, 4, 4 rows. So the first one is shorter. So this should work. Wait. So let me just let's make it even simpler. Okay, so if there's 3 items, let's say x, y, z, what are we doing? So that's one row and repeat it. Okay, 1 or more. Now, is it possible for 0 or more? Rest rows. So you want to condition, okay, with a condition such that you reverse the rows and splice. Gotta finish this problem. Reverse rows, reverse the rows. Okay, so but make sure we got rows though. Are you sure we got the rows? Can we like print? It will do something. It will print every time it tries to match. Yeah, it does print. You see, print. Wait, it got the whole thing. So this is okay. So now we're getting somewhere. Let's see. Pound 1, 2, 2, 1. Okay, 1, 2, 2, then 1, 2, 1. Okay, it's actually printing the whole matrix. So this is wrong. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It's printing the whole matrix. So when you do this one, it already matched the entire matrix. Yeah, obviously, because you are saying any row 0 or more. Okay, now but Pattern matching business is insane. Yeah, it's like regular expression, except it's more even complicated. Regular expression takes a year or two to really master. But here with the symbolic patterns on expressions, there's one significant difference with compared to regular expression is that you can you can match nested things. So then there's a whole more complexity, because even with regular expression, which does not allow any, you cannot use it to match any nesting. Even with just that, in some cases you have exponential growth. So here it's even more. But anyway, but this matches the whole, but why doesn't it tries to continue to have why is it just matching once? I mean, it should try with rows being just one row, then two row, then three rows. So okay, then so oh god, this is too complex. Fuck. So we have to go back to drawing board. So I mean, let's try something else simpler. Let's try to find the adjacent lines. Okay, you can do that by row. Okay, well, row x a. So that is a row, and actually okay, so row A is a list. Okay, that's okay. Then okay, row A is a list, row B, and anything 0 or more. Okay, 3 triple underscore means 0 or more of anything. Okay, so then you got row A, row B, then okay, so this needs to be row B. Okay, then anything this remove. Okay, so that will, let's remove that, and we need to add a condition. Condition, give a parenthesis, row A, row A, row A, row A equals to is the same as row B. Okay, that will return. Okay, you don't want to use match, you want to use cases. Cases will return all possible cases. So cases take 2 arguments. The first argument is whatever expression. The second argument is a pattern. In our case, our pattern is that with the condition of that. Okay, now let's see pattern syntax again. Pattern, yeah, condition, yeah, slash, semicolon, okay, shortcut. Or you can write the full word, condition. Let's write the full word. Condition. Okay, so condition has a syntax. Condition, yeah, it doesn't, it only use the short syntax. Condition 2 arguments. Pattern and test. Okay, so you got to have a pattern, then you got a test. Okay, so we can, we can see if that works by, I mean, the proper syntax we can see by that, and by let's say x, let's say this is our pattern. Okay, and then let's say with the condition. So we do that, hold it, don't evaluate it, then we call full form on this thing. So this will give you the full syntax for condition. there it is. So you got the condition, you got two arguments. The first argument is that a list of patterns which correspond to this xy. So list, then pattern x blank, pattern y blank. Then the second part here is the same q xy. So you see that's a full form of condition. Got that? So to rewrite that with our condition, we can just say there, and the condition, a pattern with this condition added. Okay, second argument. Okay, so if we do that, then it will list the line 2 and 3. Okay, and what is it? Fuck. 1, 2, 3, 4. No. Yeah, I mean, this is, we just have to work more on this. We're getting closer and closer. So now it returned two things. Why does it return two things? That because there are two cases, that two sub-expression that this match. So the only thing, so cases, let's see, what is the default level spec cases. This I'm not doing a good job, because a simple thing that you can do it in a loop in 10 minutes is becoming too complicated. But that's why I'm doing the advance of code, because it gets you to exercise, because I haven't used, I haven't really coded Wolfram language that much since 1990s. The default value for level spec is 1. Yeah, so is 1. That's right. So is 1. Okay, so you don't want 1. The level spec you want to that's a bit more complicated to explain. The level spec you want it to, because when you have a tree, when your expression is not just flat list, because we have a matrix which is a list of lists. Each list is a row, so list of lists. So when you have an expression that's not just a flat, then you have, when you want to try to specify a pattern to match it, basically you are trying to match a tree. You have the issue of what levels of branch, what depth you want to match, because a match can happen at several depths. So that's why it's more much more complicated than regular expression, because regular expression is just flat. So what is the level we want to match? Level 1, and see, we want to match this. So this is our pattern, basically. This is our pattern. We want to match at 0. Okay, so wrong. 0. Let's try. So when it matches, now what does it return? So you need to when it match, it just return the whole expression, I think. 0. Zero to 1. Okay, so yeah, so it returns. So you need to replace it by, let's say if it match, you return F row A and row B. Okay, if it match. Okay, now let's try again. Shift enter. Fantastic! Is that beautiful? Now we are talking. You see, this single line gives us the rows, the adjacent rows that are the same. Yeah, so so what about this one? Why is this one happening? Let's go see. So we are talking about matrix 1 here. So what is this pattern? Pound, 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 starting with 5 pound. Where does that come from? Oh, it came from here. Wait. What? Which one matrix is this? Oh, matrix list. That's we be all along. We've been working on this, both of them. We just want to focus on the first one. So let's do it again. So not matrix list. We want not the matrix list. Okay, we want just the first matrix list. Okay. So go back here. Regroup. Okay. Now third argument 0 to now. Oh yeah, so now we have to redo the level. Yeah, so level level 0. Okay, so yeah, I think so. Let's try. Okay, so we are working on the first matrix. Okay, so which is this, and it will return the rows that are, oh, we forgot to use the transformation function. Okay, so you need to, so when you match, you want to replace it by okay, you want to replace it by that. Okay, so let's see. Finally, you see, now what if you have the second matrix? This is fantastic. Okay, so let me just go here. Let's put that there. So this is working, and now let's try. Okay, now we remove that. Let's not use match. Okay, so this remove those. We kind of try to work. Remove match Q. Okay, so this is what we want, and I mean that's not the final result, but suppose the let's not use pad, right? So what is the full matrix list? Okay, so where is it? Okay, so the full matrix list. Okay, so now let's try the second one. Okay, this will return the second one. You see, pound dot 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 pound pound dot dot pound dot 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 pound pound dot dot. So you see, this is the second text block. But now let's find all lines, adjacent lines that's the same. Okay, so it says it did find it, because otherwise you wouldn't get this F. You are replacing that any occurrence of that pattern by just FF. Okay, so you found it, and that's pound 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 dot pound pound. Okay, so there it is. So they are all wait, what the fuck? Okay, the second one is horizontal symmetry, right? So anyway, at least we have successfully used pattern matching to find the adjacent lines without actually writing code, like this map and partition, and apply and position. So yeah, this is going somewhere, so this returns the rows that has the horizontal. Use pattern matching to returns neighbor rows that are same. Okay, now so the fact that it only return one item means there's only one pair of neighbor rows. Is that true? That is true. Neighbor rows that are the same. What about the first one? The first one also return one item. You see the first one is result is here. So, but what if there are more rows that's the same? Well, they have to be adjacent. So, yeah, but that can also happen. Two adjacent same row and somewhere else. So it could return more than one result, okay? More than one element. But in any case, so this using pattern matching will return a list of adjacent rows. In this case, it's only one pair. A list of pairs, okay? And okay, so then so we are we at this point we can, instead of using cases, we can use position to return the index of these rows. For example, we can use position, pretty much the same. Okay, just use the position function. Okay, position function, it takes a pattern and returns the position with where this pattern occurs. So level spec, what should level spec be in this case? Okay, so we can do that. For example, let's show it. So but you cannot do the replacement. So for example, let's remove that. So that returns empty. Wait, level spec position matrix 2, something like that. What? Fuck. But anyway, it can return you the index instead of the item. Okay, but something we did wrong. I don't know what that is. It requires a lot of thinking. Okay. Why is it not working now? So, but this works. Yeah, that works. But why is the position? So you have to think about the level. What level is it? It should be 0, okay? And it returns nothing. What about 0 to infinity? Okay, it still returns nothing, but I don't know what's going on there. Oh god. So but anyway, so this returns the pattern. Then you just need more yeah, then you need to find the mirror line, not just the where they are. You need to determine the whole matrix. Do they have the horizontal mirror line or not? But we can, but we work on top of this. So this pattern returns you. So you can, if you name the rows most, so you name the pattern rest. Okay, so if you add the rest of rows, then with a condition that in this case you want to know So we are going back to this kind of thing. Wait, not we are going back to that reverse kind of thing. Oh God. Yeah, here. What? Where is that reverse? Did I delete it? I did. Okay, so oh God, so we have to check the reverse, the row reverse. God, this is no good. Hey, coffee. Okay, I want to stop. It's been 3 hours basically, going nowhere. Fuck. Failure. This is actually just failure. Yeah, but it's not. I mean, it's not. It's common. Okay, so you want to do this problem. You don't want to do a imperative style. You want to do purely functional style, and you don't want to manually check the length. So that's kind of like artificial thing. I'm doing that with Wolfram language, because if you are given Python, you have no choice. You don't think about like, so what is our problem? I described the problem here. You just check the length and check which one is the maximum or minimum, smaller. Then you drop the extra parts, then you finish your job. So I don't want to do that. So that, for that it takes 30 minutes and not done yet. Then rifle is probably the solution, but maybe not. But anyway, then we want to do pattern matching. So this problem, I'm 98% sure that this problem, given a matrix, one single pattern matching function call can tell you which line, if can tell you that the line number that is the horizontal mirror line, or it doesn't exist. One single line of pattern matching. Okay, so we went on to do this, and we made some progress. Okay, we made some progress. At least we so far can use pattern matching over here to return the two adjacent neighbor lines that are identical. So that's the seed of the horizontal. One of the first condition must be. So we made some progress there, but the part is that we need to reverse, all the lines before this row compared to the rest of lines and see if they are equal, and ignoring extra number of rows. Okay. So what we need to do is we modify the pattern by adding more. For example, here you see this triple underscore. That means 0 or more items. That's what I start to do here. So, any 0 or more row, then one of the row, then one of the row, then the rest of rows. Okay. Then you give a condition that says row A equals to row B. Okay. Then you need another condition such that the first and row A together, you reverse them, is the same as the row B plus the rest of rows. Okay. Yeah. Okay. So that's, you just need to add another condition. So you have like kind of now a nested condition, another condition within condition. Okay. Can you do that? Yeah. So okay, actually you don't have to nest condition. You can do an AND. Wait, maybe not AND, because does condition return true or false? what does condition return? No, condition is just a pattern. It actually doesn't return. But anyway, you can have an end. Like pattern matching. In pattern matching, you can have alternatives, or you can have like both of these conditions must be true. I mean, both of the pattern must be true. Okay, somewhere here. Okay, longest, shortest, and when you have longest, shortest, it gets exponentially complex, like regular expression. And so yeah, but the result will be spectacular. So you also have orderless pattern, because the result will be like one single line like this that tells you a matrix has a symmetric horizontal line. Okay, that made me think another issue with this problem is that, you see, so far the symmetry is between the rows, but it is also possible for a matrix to have a horizontal row symmetry such that the center of symmetry is one row. Okay, is that part of the problem? It doesn't. I mean, I don't know if it's described precisely. That's they don't. So that's another thing to look into. So anyway, so one single line using pattern matching that without just specify the patterns. Just I think I can do it, but now I'm tired. 3 hours. So actually we deleted the code before, but basically the condition will be the condition is that, okay, so this so this is one of the condition. You have adjacent row numbers, but the other condition is that you need to use match Q. Okay, so actually so instead of cases, you match Q. Match Q will match the whole expression at at level 0. Okay, so you don't need to worry about the level spec. So you match Q. So you want to match this pattern. Okay, expression form. Return true if expression matches pattern form. Okay, that returns true or false. Okay, so you can see some examples here. They match plus, they match whatever golden ratio equals to 0. Okay, so yeah, they trying to determine if an expression is 0. You just use 0 as the pattern. Okay, so pattern matching is very complex, and they are doing more fancy things. So here is a pattern with a function to test, and also it involves association like a hash table. And this, look at this, is a weird, getting complicated Wolfram syntax. Okay, so and here you want to match, but anyway, so that, okay, I'm pretty sure match Q is what we want. It returns true, then it means this matrix has a horizontal line of symmetry. So one single pattern matching, but what exactly is the pattern? So we need to so a pattern with a condition. So how do I add more than one condition? So let's see. Condition, expression, you don't have that. Okay, so you don't want that part. So condition, so second argument. So the first argument is expression, the second argument is a condition. What condition? A equals to B plus and. Oh, so now here you can use and. Okay, so and Do we have a shortcut? No. And okay, so and this, and another condition is that you want to somehow the first, so let's not use the first word, let's say front. Okay, first replaced by front. Okay, so condition front and rows, but you want to make them one single list. Okay, so you splice front. Okay, forgot what is the sequence. No, you want to splice. Okay, yeah, so front and row. So that's one thing. You want to check if this thing, and you want to reverse rows. Yeah, fuck. You see, when you, I mean, actually over here, you need to do another pattern, because wait, do we need to do another pattern? I mean, yes, because otherwise, because what we want to do is like this. Okay, what we want to do is like, you want to check if two items are the same. So the first item, did I just delete that thing? Ah, fuck, I did. So we want to check the two things are the same. The first check is one group of list, this is whatever before the mirror line, is the same as the second group. Okay, so this will be row A. You know, reverse of row A is equals to row B with the rest. Okay, so this will be rest. Okay, we want to check the reverse of whatever comes in front of the rows is equals to the row B with the rest. Okay, and, but however, when the rows have different count of items, then this won't work. They won't be the same. So what can you do? Then again, you either write a function to like to you know, to see which one is more number of items. Then you cut the one that's shorter, you know, that's longer, you know. Or so if you don't want to do that, which we don't want to that, we don't want to. We spend 1 hour trying to not to. But if you don't want to do that, then again, you start to use a pattern. So you actually have a pattern within a pattern. so here, instead of this, you have to say, so wait, what is this, the rest? Okay, we don't need this rest here. So yeah, so one of the solutions here, it gets, you know, its nesting start to get problem. So let me try to format it so you can kind of see. And yeah, condition. So you see, actually we need you know, condition. Yeah, then you know, match. So match takes two arguments. One, the first argument is the matrix itself, the expression, the second argument is a pattern. It checks if this matrix matches this pattern. Now, what is this pattern? This pattern is a condition, meaning that you match this pattern, but then this condition, which is the expression, must be also true based on whatever named things you have in a pattern. Okay, so you want to check this pattern, front, row A, row B. First of all, you check row A and row B are the same, and then you check that whatever comes in front of row A and the reverse. Oh, okay, so you reverse it wrong. You want to reverse not row A, you want to reverse this whole thing. Okay, so whatever comes in front of row A plus row A, reverse the whole. You want to see if it's same as row B and the rest of items. Okay, then however, you got a problem here, because if the row numbers are different, this always fails. So how do you solve that? Well, you can solve that by starting to check the length of the rows, like the problem we have here, like this problem. Then, drop the longer one. So you have to write a function to manually do that. So instead of doing that, if you don't want to do that, then we replace this part by another pattern. So let's, so replace this same queue by another pattern. Okay, so match queue. Okay, so match queue. So yeah, by another pattern. So what is the pattern? This pattern would be another condition. Okay, so this pattern will be so the available values are x front, B row, B rest. Oh god, so another pattern. Okay, I need to stop. Thank you guys for watching. You guys are still here, but now it's 3.5 hours. Yeah, I continue 1 hour or 2. I'll finish it eventually, but this is not good, I mean, but it's kind of common. Okay, if you wanna, if you are trying to do it this way. But the whole solution will be beautiful. It's just like just 200 characters. Yeah, but so you want to, so can you actually use another pattern? Yes, the match queue will always return true or false. So you can use it inside AND. AND means several arguments must be true. So first of all, row A and B must be the same, adjacent rows. Okay, then we want to know all in front of the adjacent row and rest of adjacent row are the same when you reverse them, because they are mirrors. You see, match. So the rows, they need to match outer pairs. So how can you do that? You can just reverse one of them. Can you? Did we forgot something? Actually, we need to based on the shorter one. You can't just, okay, another issue. You can't just, the shorter one must come in front if you want to do it that way. Okay, let's rethink. Okay, is there a way? Just reverse the whole thing. Okay, doesn't you just reverse the whole thing, and you just add this 0 or more patterns that will be able to pattern match. that's the beauty about pattern matching. You don't have to be specific. You can just pad a pattern by 0 or more. So all we care is that one of these, so we are given 2 lists of rows. All we care is that one of them matches a sub-expression in the other, okay? But one of them, they must reverse rows. So the smaller one, the smaller ones, you need to reverse their order. That's right. We have to write it out. Oh, God. So we given 2 lists of rows. We want to know if so we want to know if we reverse the one with smaller length, it is a sub-expression of the other larger. Okay. Now, if they are same length, then everything works. We can actually, no problem. But if there's one of them is smaller, then we need to do this. And this can be done with pattern matching. We can start, the next step is to start with a toy example instead of using our matrix, because we use the matrix that's complicated to compare, which we can just use a toy example. So for example, each number represents the matrix. You can do that. Do that. So for example, okay. Paste random number, paste. So imagine each number is just a row. Okay, so you have these 2 rows. Let's see. Okay, so imagine each number represents a row, a toy example. Then 156, that's the row A and B. They are adjacent and same. Then you just want to find out which group is smaller number of items. You reverse the smaller you reverse the smaller one. Then you try to match pattern to see if this reversed smaller is a sub-expression of the larger. But order must be the same. Okay, so in order to test that, you can, for example, test, we can, for example, start with given 2 groups. This is already given to us. Okay, so one like that, one like that. Okay, so we are given this 2 groups of rows. Then we try to use match. Then we start to play with our pattern. So and we know, so that, so we start to work on this, which is okay, so so what we do, so we, oh God, okay. Let's try to get something actually works. Okay, so so we actually show, so this works for sure. so let's work on that. This is a matrix list. Okay, so remove that. So conditional, so given a condition, a pattern, let's not, okay, there's condition, row B, A and B. Okay, let's add some items here. Okay, let's first of all assume the row numbers are the same numbers of items. Okay, 1 2 3 4 5, 1 2 3 4 5, same row numbers. Okay, oh, then you must also make sure they have the same numbers. That's annoying. God. And God. Okay, let's just cheat. Okay, let's do reverse here. Okay, reverse, add that, evaluate. Okay, we got that. So for our testing purposes, we can, this is our test case. 156, 156, 963 check, 94 check, 593 check, 646 check. So we got, they are, so if we have this matrix, they are, symmetric. Then this will return true. This thing will return true. Hopefully. I don't know for sure. Wait. So this part needs also to this part is not splice. So hold on a second. Let's see what if you splice with a empty brackets. Okay, let's say T. What? Okay, so you need, so basically you need that. Let's say 3. You just remove the bracket. Okay. So, but what if it's empty? What do you get? Yeah, so that works. But what if can you like have 2 of them together? No. Yeah, splice only takes 1 argument. Yeah, so let's see. Yeah, it takes only 1 thing. Okay, so okay, but it can be empty, right? Empty also works. Okay, so now you see, so now you got, now the fronts is potentially 0 item. Okay, so what if you splice with a 0, no argument at all? God, it doesn't work. And so this you got the issue, because this named pattern, these fronts, what? Oh God, we named it wrong. FRONTS. Okay. Let's see. Okay, rename fronts to just front. Okay. Okay, so this fronts is potentially no item at all. It's a list. Okay, it's a list of 1 item or 2 or more, but also 0. So when you, but when we have seen this, when you call splice with 0 items, it's got a problem. So a better way to do this, so instead of splice, front is like what, 0 or more items. 0 or more, they must be a list. So let's be specific. Okay, the rest is a list too. List means a row. Okay, so now front is a list. Okay, so let's check sequence. Let's check sequence. Sequence is also like splice. Okay, so sequence. Okay. Okay, so I mean this is a normal kind of normal Wolfram coding session. It is indeed like this. I mean, even if I'm coding by myself, I kind of have to do this kind of thing. So when you do sequence, what you get, nothing. So sequence expression 1, 2, 3. So normally it's something like 1, 3. Yeah, but that doesn't work. You need a bracket outside. Okay, so this is a more normal usage. The difference between sequence and splice is that for sequence the arguments are not lists. For splice the argument is a list. Okay, so the typical example of using splice is like list more than one item, like that. Okay, yeah, it basically just remove the brackets. Yeah, so but for sequence it's you see it returns that. Good. What if you just have one item? Let's say it's 2, not 1. Okay. So what if you just have one item? Let's do it. Okay, 2. Yeah, that's good. Now what if you have no item? What you get? This should be, it should return an empty list. Yeah, it does. Okay, I don't know why something I did wrong before. Okay, so here is a sequence here. So sequence allows, you see, splice nothing is error. Yeah, that's actually good. That's a good thing, because splice is, you're supposed to have, you know, a list inside. So but when you have a sequence and you give it nothing, it returns nothing. That's good result. So here we want to actually, what you want to do is you want to, yeah, I know what to do now. So you want the sequence. Okay, sequence. Okay, but you want to apply the sequence to that. This gets complicated, but just trust me. Okay, and the rows, yeah, the row A you don't want to. Okay, so then, okay, you need to do the same for the rest. So this sequence something add something to, is to, it basically it's to make sure that, you see, you have a list of rows, but here you just want the rows, you don't want the list. You know, because or alternatively, you can, a more easier way is you append row B to the rest, and here you prepend, I mean you append row A to the front. That actually is easier. But if you do, I mean easier to understand, but if you do append, what happened is that you need to test. For example, let's say 1 2. Okay, we append 3, we got 1 2 3. Okay, right now, but the situation is that what if you append nothing at all? So I mean, yeah, so this front thing, because they are pattern matching, this front stands for 0 or more lists. So when you got 0 list, you got a problem. You can't, I mean, when I don't even know what 0 list is, you got a problem. So you cannot use append. Okay, so that's why we are using this sequence will work. Okay, so this is our test toy example to see if this. So what does this do is that you attach the rows in front of the row A and you reverse it, then not same queue, you want to see match. Okay, so this needs to be another match because same queue doesn't account for different row count, but in this example there's the same row count. Okay, so this will work. Double check one more time. Sequence, you don't want that. Okay, so sequence add font. Okay, double check one more time. Okay, so let's evaluate this expression. It should return true. Okay, do it please. Oh, false. What the fuck? Oh god, what the fuck. Now how do you debug this? Well, I mean, you have to use some other pattern match, because match queue always just return true or false. But you need to dig what the heck is going on. So can you like print this thing? I am not even sure that will work. So let's use a compound expression. This print is just a side effect. It doesn't do anything. Okay, so, but I don't even know if that works. You see, it's still false. Yeah, I don't think you can use print here. So you need to change the match queue to like cases, like we did before, cases, so that we actually see, what is going on. God, wow. So okay, so let's move this to our test pad. I mean, to our playground. Okay, so that's about sequence. And back here, so so you want to use cases, then okay, I'm right now I'm a case Q. What's going on? Case Q, not lowercase. Fuck. Case Q. Cases. Okay, it is cases Q. Okay, well, not Q. Okay, it's just cases. Okay, so we are right now. I'm a living zombie, just mechanically drill down, trying to work this out. A living zombie without thinking out of the box. Maybe you shouldn't do this. Maybe you should. But let's play with the living zombie part. So what is going on if you use cases? Jesus, what? So cases, you need an extra optional argument. You want to match the whole expression. Okay, I don't think it'll work. It just empty. Yeah, so you need to think about what is exactly going on with this thing. Okay, Dan. Okay, thank you, Dan. Yeah, so what is this? So what the so cases reverse sequence. We need just to test this. So sequence is a rest. What is the rest? Rest is like we forgot. Wait, the input, the toy input is incorrect. Fuck. The toy input should not be a sub expression. It just should be just like that. Okay, it should be just like that. The toy input is fucking wrong. You know, it's a minor mistake, so it's not that. Okay, so let's put that to the bottom. You know, comment this out. Yeah, so that is supposed to be the, you know, that's what we are trying to match. You see the front row A, row B. Yeah, so the you got it wrong in the first place. Of course, it's no match. Let's try this one. Do it. False. Oh, then it cannot be a list. Okay, then it should be an integer. Okay, you need to change all this list to integer because this toy input we try to use integer to represent a row. A row is a list. Okay, a matrix row. So now since you are using integer, you need to replace that by integer. How do you spell it? integer. Yes, do that. Okay, now let's eval this. Please let it be true. Options expected instead of 639 beyond position 3 in apply sequence. Oh, what? Oh yeah, then we, what is the sequence? Row A. X front. Oh, X front is not integer. Wait, yes, it is. 0 or more integers. So there's a sequence of 0 or more integers. What are you saying? Optional expected. Options expected. Instead of 639, which one is that? 639. Instead of 639, beyond position 3, beyond position 1, 2, 3. Okay. In here, so it's actually trying to, you see this at that is the apply. Okay, so you are saying Wolfram language is saying that, so we are trying to evaluate this sequence options. So this apply is used wrong. So what is the front? The front is actually possible 0, 0 or more integers. Now let's go back here. 0 or more integers, right? Does that work? 2, 3 works. One single number, does it work? 2 works. 0 items, does it work? Oh, but then you are doing apply. Fuck. Okay, so you are doing apply. Fuck. Let's check again. Oh yeah, so don't do apply. Fuck. Okay, there. Okay, run it. Oh, true, the most beautiful thing for the fast hour. True. Truth is beautiful. Okay, so this part works out. use pattern matching to return neighbor rows that are the same. That's what we are doing. For this example, we use integer to represent a matrix row. That's what it is, okay? But it works. However, the next problem to solve is that we need to check the cases when the row numbers are different. In this case, the row numbers are the same, you see, before and after. So, 1, 2, 3, 4, 4 rows before the neighboring row and 4 rows after. But if the rows are different in length, you got a problem. So where is it? So yeah, so cut, paste, make a line. What the fuck? What did we do? Cut, undo, go down, make a divider, paste. Okay, yeah, okay. So now we have a copy. Now let's work on. When the front rows and rest rows have different length. Okay, now that's when you use, we need to replace this same queue with a pattern. Okay, let's do that. Okay, we went so far, let's do that. However, it takes zombie coding style. Match queue again. You want to match. Okay, what do you want to match? Well, you want to match, first of all, you want to match a expression. And what is the expression? You are given, okay, now you are given the expression. We can actually create the expression, okay? You are given something like that, okay? Front, row A, row B, rest. Okay, and your sequence thing is still useful. Yeah, so we want to do, you want to match, okay, first of all, what you want to match is front and rest, okay? Front and rest and reverse, okay? So basically you want to match just these two expressions. I mean, this one single expression just made out of front and rest. Either one of them can be zero item, like empty, okay? So you want to match, and we kind of have to go back here. So we have to create a new pattern, because the new pattern will accommodate like extra rows. Okay, so again, we can break out into a toy problem here. I mean, a toy example that purely focused on this. Oh God. Yeah, so again, we break out into a toy example. Let's remove that whole thing. So actually remove that. We got a toy example where we got, this is where we are before, like front and back. This time, let's say the back is missing an item. Okay, so so this is our example. We want to match this. This part is the front, this part is the back. Okay, and we can use the word front for it because it's named pattern. Okay, anyway, so front and back. how do you want to do it? And but this could be 0 item though. That's the thing you want to be careful. So the whole thing can be like empty list if you do it that way. Tricky, you know. So, but what do you want the pattern to be? Well, the pattern now can be, again, we utilize the triple dot, which means 0 or more. Okay, that can, you know, like just like before, just like what we did here. Let's try it here. So, you know, let's say new font something, and here's new rest. Okay, and then you don't need the row A and B. You don't need it because they are the same. We already know. But you want this pattern with a condition that but this pattern you need to also add new font. Okay, wait. Oh God. I need to think. Do I want to solve this? Yes. Now my drink is gone. Okay, another 5 minutes break. Okay. Another 5 minutes break. Let's clean up our code. Where are we going? Let's clean up our code so far. Let's see, you know, we're gonna work 10 hours to finish this problem. Since we, so what is this? Does it work? No, because you didn't define the things above. So before we were using like the functional, manual coding. But right now, so manual coding up to this point, okay, up to here. And we didn't finish the functional, you know, it's functional programming, but it's compared to pattern matching, it's more manual because you are telling it exactly what you want to do. But with pattern matching, you don't even, you don't have to like exactly tell it. You just find if the pattern is correct. Okay, but the trick part is to come up with a pattern. Okay, that's what we are doing. But anyway, the first part is we are trying to, functional programming. So far so good. This is the matrix, X matrix list. Okay, then we test out using the first wait, this is not actually, this is the first matrix. Okay, so actually matrix list and the first matrix here. Okay, so this is the first matrix, looks like that. And then return a list of int, each is a row number. Let's clean that. Let's put it, return a list of int, each is a row number, means it and next row are the same. If empty, then no same adjacent rows. Okay, if empty list. Okay, so this is how we use functional programming, and actually also contain pattern matching to get the adjacent same rows. Okay, index of. Then what do you got? Then we got, okay, so two possible result is that empty or a list of indexes. That's the adjacent row. Then we get the first adjacent same rows. Then we do something with that. We kind of stopped here because we want to be able to, because we don't want to, we refuse to manually check the length of row count, compare them, find which one is minimal, then drop the extra row count, then reverse. Actually, we can do that. We, let's just do it manually, and we solve the problem. Fuck the shit. Oh God. Okay, so that's a summary of where we are for the first approach. Okay, the first approach is that, you know, is this thing is we don't, you know, we refuse to call the function length. We want to have a more, how do you describe it, kind of like more mathematical, by a mathematical condition or mathematical way of expressing, you know, ignore the extra length. So we tried rifle. Rifle is kind of on the spot. We, you know, map thread is what we want to do, but map thread does not ignore when one of the length is got more items. So map thread is just map the function to each element in the list. You know, they feed. You know, if you have 3 lists, the function receives 3 arguments. If you have 2 lists, the function receives 2 arguments. You know, so map thread is what we want, but map thread does not ignore the extra items in the list. It gets an error. So that's why we want to, you know, maybe use rifle. But the easy way is just to, you know, manually check length and drop the item. Okay. So anyway, so this is a sub problem we get into. So now, then we went into the pattern matching approach. Okay, like pure, like the using pattern matching to solve the whole thing. Okay, so first of all, this one will return, will get you the rows that are the same adjacent rows. Okay, which one? This one. Fuck. Yeah, because you didn't evaluate it. Okay, so you know, you need to evaluate the code before the code. So what is this? Oh yeah, so this is the first matrix. So this works, we know, because we tried it. You see? Fantastic. Okay. And then we tried the second one actually. So actually we can just use that, you know, the first one. Okay. But you need the list. So where can we get the list? Well, the list is here, so you can copy. I mean, so you could put this here. Okay, and then you evaluate. Okay, yeah, you will, but what? Empty. But yeah, then you need to grab that. Fuck. You see, then we need to copy this. Okay, we can do that. It's not too bad. So, you know, this single line solution. Okay, let's run it. Shift tab E. Split string problem. But now, God, then you don't have input. Input is a string. Fuck. Then you need to copy this whole thing. That's no good. Fuck. Oh God. So let's forget about this whole. Let's just use this. Okay, this is the matrix number 1, the first text block. Okay, that works. Then so let's, I mean, here is the what's doing. Use pattern matching to return neighbor rows that are the same. It does that. And here's another test on second matrix. Okay, it also works. Let's try it here. Do it. Yes, you see they have different results, because both the first one and second one happens to have a horizontal adjacent same horizontal row, right? But the first one actually don't have a mirror horizontal line. It has a vertical. Okay, but once we solve the horizontal, we can easily solve the vertical just by transpose. Okay, so again we are like I'm repeating what went so far. So this works, and then okay, then we don't need this one. Oh yeah, we added the name front and rest. Okay, delete that. Then okay, then we are trying to use pattern matching to solve the whole problem. Okay, to find if a matrix has a horizontal mirror line. Okay, so this code is not working because we have the issue of the length. And also it's using splice. Okay, but anyway, it's not working. Given two lists of rows, we want then sub problem. We want to know if we reverse the one with smaller length. Okay, so that is that. Then we yeah, so this is not working. Then we go into a okay, so we use an integer to represent. So delete this even. What okay, what you delete? You got an extra. Okay, so anyway, so then we use a simple example to test our pattern. That works. Fantastic. Okay, so we getting better now. It works when the before number of rows and after rows are the same count. Okay, but the issue is when they are not the same count. So we use another toy input to try to get it. And okay, then this part we delete. Okay, so now we are at this stage, which needs more thinking. So but break. Okay, I suppose now nobody is watching. 7 7. Okay, but anyway, so let's move, let's go on. Let's break time 10 minutes. So but can I like put this onto the web first so you guys can see, kind of where's today's talk show? So here's today's talk show. Yeah, because if I put this up, then people can see what is the current state of the art. Let's do that. Okay, so backspace B to pop this back, make a backup, syntax color show in browser. So this is so far what we have: the toy input, the algorithm description, and algorithm exploration. That's all still correct. And some thought process, crazy edge case situations that this idiotic event of code knows say. It rewards the brainless. It punishes those think thoroughly about the problem. Well, supposedly part 2 will deal with that. Part 2 will punish those those brute force, according to Steve. So anyway, we got the situation. So here's our code. Let's upload the code so people see what is going on. Okay, so let's do that. Control X, the PowerShell multi-language exploration. PowerShell. So all you need to do is say XOR rsync, rename rsync. There it is. Okay. Do that. Let's. I have to type password. So let's stop screen for a moment. What is this? desktop show. Okay, my brain is somewhere. Let's see. Desktop audio input or Logitech. So let's try this one. No, not that one. That's keyboard. I want. You gotta see my hands. Not that one. That's face. Oh, display there. Okay, so sync server. Okay, so sync it. Okay, are you sure? Yes. And fantastic. Okay, so it's uploading quite a few things. Now let's see what is it. So a band of code and lots of my other website updates, a lot typing of the dead, T34 layout keyboard, night keyboard, keyboard 1000 function keys, happy hacking keyboard, light 2, buckling spring, Atrius keyboard, all update. And China, something, politics, art deco, Ferris wheel. Okay, so now, okay, so let's close this. Yeah, so close this. Now return the screen. Now you can see nothing happened. Now, so now you go to Xa Talk Show. It's on YouTube description. Okay. So now break 10 minutes. Be right back. Wait, what's going on? So wait. Magnify the full glory. Now you need daytime, so let's insert daytime. You need the full daytime. What the American this ISO date full time. Okay, so to be back in 2018, 16 o'clock and 25. Spectacular. Go to here to see the current state of the art. The art. Yeah, perfect. I'll see you guys in a bit. Now today's wolf. Okay, beautiful wolf girls. We have to show that. No comment. Comment, guys. Yeah. Now I have to remember to turn back audio. Okay, I'm kind of back. Make sure I don't have 4 messages. Okay. Everything good? Let's see who is on Discord. Who is talking? First picture, Wolf. Second picture, the girl. Okay, programming. So we are doing programming. Okay, we are back. So everything check? Yeah. So back to code. Yeah. So this is intermission. Okay, intermission. Close it. Now we back to code. Make a backup copy, delete that, and showing browser. Go back here and pop this out. Okay, back to code. Still same problem. So before we we use functional programming without real pattern matching. That all we have to do is just check the length. Okay, that will make things, we can do this, we can just solve it if we just check the length. Yeah, so the problem is when you want to actually do them kind of in a perfect way, then it's be 2 or 3, 4 hours. Okay, so if it's empty, then first it's empty. So otherwise you just functional approach is, it's kind of simpler. So functional approach, what's the first step? So you need to map this. Okay, each row number of the adjacent same row, you need to try it. So this is just assuming one adjacent same row, one pair, and you want to compare reverse take, then okay, the function, then you can, it's you can easily do that, but it's just, let's try to complete the functional simple kind of approach. That we can do in 10 minutes, I think. Okay, then thanks for watching. See you later. Yeah. So so let's just do the function. Okay, and all you have to do is just use width. Okay, so width, then you assign 2 variables that that is, so you give it 2 variables kind of. So the first, let's go at front equals to that, and rest equals to back. Okay, so that is a constant. Width is a way to allow you to define local constants. So we define local constant front, which then take the first same index. Yeah, that's the index. Wait. No, that's wrong. Okay, so let's remove that. So first same is the index. first same, so you have the index list. So, but what's the first matrix? Same index list. Okay, that's actually for the first matrix. Yeah, so this actually needs, so the first matrix, let's put that first matrix there. So actually, let's not put the first matrix. Let's clean more code so we don't, yeah, so replace all first matrix by, let me show you, okay. This is what that, okay. Replace the first matrix by that, okay. So remove one global variable, okay. Oh, there's one occurrence. So same index list, that's also the first one, okay. The same index list. Okay, so the same index list is for the first matrix, okay. Then the first occurrence of the same index list. Okay, let's also remove that variable. So hold on a second, let me double check something. Okay, it doesn't occur, good. Now this occur multiple times. You want to replace all occurrence of that by that, okay. Ignore that one for now. That, okay. Now search, okay. Now we don't need this anymore. Remove one more variable, okay. So same index list is a list of items of the row number of the first row of the same pair that are adjacent, okay, like that. So when you get the first, so when you get the first one, if they are the same, oh yeah, so if the list of index is this, it's empty, then you don't have horizontal mirror. No horizontal line mirror, okay? Because that's confusing. When you say horizontal mirror, does it mean horizontal line mirror, which is mirroring up and down, or does it mean horizontal mirror, meaning that the horizontally left and right are mirror? So it's kind of but when you say horizontal line mirror, that makes it clear. Horizontal mirror line, okay, that means that's clear. That means up and down are the same. So if it's empty, if this same index list, let's double check, same index list. Yeah, we are, right now it only works on that one. So this, this code needs much more clean up. Yeah, so, yeah, but I'm taking too long. So you define a local variable. So the tech, yeah, so you map it to what? The function. The function takes x, yeah, so you want to, so what is x? X is an index, right? So x is an index, okay? So let's just write that. So you take that, okay, you flatten, first of all, this same index, you don't want this nesting, just flatten it. Okay, so we just flatten it. Yeah, actually just flatten. Okay, at is a short syntax for the square bracket, so it's a prefix notation, so you don't have to nest the square bracket. So you say flatten, okay, flatten, and the position actually takes another argument of level spec, okay. So position, so if you actually give it a position, it makes it faster. So you want to level 1 only, so position true and level just level 1, that should return same. Then you flatten it, so same index will look like that, or looks like like that, okay, list of numbers, okay. So if the same index is equals to empty, then same index list, first one, what, why is it first one, same index? Yeah, you don't need even first one, same index list. Okay, so potentially it has more than one item, right? So it's empty list or more than one item. So, but if it's empty, then there's no horizontal mirror line. You need to rewrite this in a functional way here. But if it's not empty, we need to do something, okay? So that something would be, so you start, basically you need to map a function. You map a function to each one of these indexes. Each one of those number means, if it's 3, that means row number 3 and 4 are same. If it number is 7, row 7 and row 8 are the same, okay? So you need to, try each one. So you write a function to map this list, okay? So actually you can just map. You want to map, but once you find something is true, you want to stop. But okay, so that gets another complication. So if you want, so that, for example, let's go to my Wolfram language tutorial. You'll find some Wolfram language tutorial. So you want to loop and iteration. Okay, so in the past month, I did a lot rework on that, lots of update. So here's all the things, everything you need to know about loop or iteration with Wolfram language. It's beginning with intro to iteration. So in this case, we want, actually, we don't want just map, because we want to test as soon as we found that a matrix is symmetric around a horizontal line, we want to stop. We don't want to continue computation, right? So we don't need to check the next pair of lines that's the same row. As soon as we found the pair of lines that's the same row and the rest of the outer rows match, are symmetric, we stop. So in that case, you don't want to use map. Go back. You want to use create a list, recursion, procedural loop, scan. What is this? List operations. Okay, so so wait. So what we want to stop a loop as soon as we found a condition. So yeah, so that would be scan for each, also known as in JavaScript or other languages. So scan, same as map, but return null, and so you can use return to return results. So there's so many ways to do this. So yeah, so you can use scan, okay. So let's use map, because map everyone understand. If I say scan, people don't understand what is it. We'll change to scan later. So map takes two arguments. So the first one is a function, of course. So here is our function. Okay. Then the second one is the same index list. Okay. That's not a good name. You know, what does it mean, same index list? That's a list of row numbers whose next row is the same. Okay, but anyway, let's keep going. So you map a function, you know, so to this list. So the function takes one argument, that's an index. Then you compute the, yeah, so now you want to compute same index list. Okay, so you want to compute, that here is wrong. Here you should take the matrices. Okay, so let's go back here. So you need to take, yeah, the matrices. Okay, so you need to take the matrix. Let's see if it's defined, you know. So this is a matrix. Yeah, so you want, so okay, so here, and then you, and over here you take the matrix, yeah, we need to work on the first matrix. Okay, so you take the matrix from 0 to the index number. Okay, so let's see, take documentation, take list n, takes the first n element, right? Okay, you know, given the matrix, you take the first up to the same row index. Okay, and then you also drop the first n, so that is the given a list with its first n element dropped, so you got the front and rest. Okay, you got two lists of rows. Okay, then you do God, shit. Then you want to see which one is bigger, and fuck, that's, then you need God. So you can do not let. Why is let here even? Okay, length front, and so you get the length and see which one is smaller. If that you basically, so let's think about how to do this again. So this is our problem. Okay, so our problem is written out here. Drop the longer list of items. Yeah, you need to do that. So you want to drop, so, okay. So minimum will return the minimum of items. Okay, the smallest. Okay, so then you just can do that. Okay, you return the smaller of the either one of them. Then you take, okay, then you take God, you cannot modify, you know, so many issues. You know, we want to do functional programming, so if we really want to do that, that means we cannot modify variables, you know. If we can do that, then it's more easier. So, but I don't want to do that. So anyway, but if you don't want to, then you define more constant. For example, you can do this. So more constant, you know, a nested constant definition. So here is the smaller count, smaller length, okay, equals to that. Then you do things here, okay. So you got a smaller length, then you God, you need another. Let's see. We got several nested expressions. So then you new font equal, okay, new font equals to, okay, then basically you do that. Okay, so let me show you. Okay, x new font, x new rest. Okay, new font will be equals to take, oh wait, we got the algorithm wrong, but let's finish this part. This to finish the subthought. Okay, take front and smaller length. Okay, let's put an x there just to be consistent, kind of. Okay, and also this is not efficient, but we are like too much late. So you got now new font and new rest. Now you can actually do whatever you want to compute. Okay, so what we actually want to compute, we want to compute something like oh forgot, where is it? Same, something like here. Okay, let's copy this code so we don't have to type it again. We want to make sure that x new font is equals to x new rest. Okay, we don't even care about that anymore, so we don't need the end. So there. Okay, that's kind of it. So you see lots of these brackets, nesting. That's like Lisp. Okay, it's the same thing. So anyway, so this code over here, we are doing a map. Maps takes two arguments. The first argument is this function, and the second argument is just this same index list. That's not a good name, you know. It's a list of row pairs, same row pairs. Okay, so anyway, so the function takes the index, right, argument, one argument, then it, okay, so we have to think about this. So you got a bunch of rows. Now let's say, okay, let's imagine it's the first problem. So you got 1 2 3, the first 3 rows, then 1 2 3 4, the second part has 4 rows. Okay, so you need to reverse the smaller one. Okay, so our algorithm is wrong. We cannot just reverse it first. We need to reverse the smaller one. Right. Yeah, fuck it. Oh wait, but so yeah, don't reverse yet. Okay, don't reverse yet. just take the front, take the rest, then see which one is smaller. Okay, then you want to, you need to know which is smaller though, but right, yeah, you need to know which is the smaller. You need to know which one is smaller, not just there's the smaller count, the smaller length, because you need to reverse the smaller one. Yeah. This is real pushing on without extra shit. Okay, so you need to know which one is smaller. So this is not good. So then you have to do if statement, you know. So the pure, most elegant code is not to do any if statements. Yeah, I feel like, you know, my Wolfram language. I feel like my Wolfram language. Hello, Dan. Is you still here? Stamina strong to stream such long. Oh, crystals. Hey. Okay, so you know, the most elegant code, you don't want to use statement, you know, if. Like when you use if statement, that's like, you know, then it's like C, manual. You know, you just manually coding things. So the you know, the ideal situation, especially with Wolfram language, you know, there are several levels. So at the lowest level, it's just procedural programming. C, you don't have any choice. You know, JavaScript and Python, you can do a bit higher level. Okay, so lowest level, if statements, you know, manual loop, you don't want to do that. Assign variables, mutate, you know, change state, you know. Higher level is functional. Okay, now functional, you can say there's also low level and high. So the less pure functional programming is that you know, sometimes you mutate a variable. You have a variable, you know, like Emacs Lisp, like Lisp in general. But the more pure functional programming is that you just have functions. You don't have mutatable states like Haskell. However, you can still use if. You can have tons of if you want to. If, nested if, or condition, you know. But that's not, you know, so that's not elegant. So next level is like, you know, I don't know how you say it, maybe like Wolfram language, where you don't, you know, whenever you have if statement, you know, unless it's absolutely necessary, you know, you can try to avoid it. In other words, you don't want one bunch of if statements, like 10, 5, you know, like that's manual checking code. So instead, you want to think about the algorithm, you know, what, like, then usually there's one function that just does it. So anyway, so how here let's stop talking again. Let's back to code. So we have these two lists of rows. We want to know which one is smaller. Okay. And can you do that? Let's just code. Okay, let's just see order. I forgot what is, you know, so order, let's say 1, 2, 3. Let's say 1, 2, 3, 4. Does it put this in front? Does it work? Does it first use the length? So if you have a to list, does it first use why is this key doesn't work in Wolfram language? What is this queue? Reformat lines. So why is it? Oh, okay. So let's see. Run this order. -1. Oh, okay. You can it tells you the order, so you need to use sort. Usually most other languages you don't have this function, but you have sort. Okay, let's see what it does. So sort, put that first. Okay, now let's what about this? God, there's something we did there. Okay, actually it's ugly here, ugly. Okay, so run that returns itself. Run that also returns itself. Okay, so you want to order by length. Okay, so let's see, sort by let's see, sort by p. So yeah, so you can give a predicate, but that's not, sort by is better. Okay, yeah, okay, use sort by. So you use sort by just length function. Okay, my hand is hurting now right here. So length code with 2 arguments. Oh, yeah, fuck. Function. Wait. What? Why is the length not working? 1 argument is expected. Why are you giving it to sort by? Sorts are elements of list in order defined by applying f to each one of them. That should work. Why is that complaining? Oh, wait. Oh, so the first part is a list, right? There. Do that. That should return itself, right? But now if we reverse the order, it will reverse it back. Correct. So this is what you want, sort by. Okay. Sort by, delete. So let's delete that. So we can use sort by to deal with this. Oh God. So sort by, drop. Yeah, but what are you doing? So this will give you the smaller one in front. But take matrix index sort by. So now I'm like, I really want to stop, but let's consider this is death march. You have to continue or you're gonna die. And continue until you finish it. Okay, so we got a 2 list. We need to you need to compare each one item. So you say a better way. So drop by, so you just minus. Another way is if you minus, can you so I'm just going to try so many things. Okay. Let's see, does it give you okay, cannot combine. Fuck. What is the rifle? So rifle interject, you want the smaller list in front. Okay, so let's go back to the idea of rifle again. We tried rifle. What? Oh, okay, so it's back. So we tried rifle here. The smaller first. Let's see, A, B, C, D. Okay, It's easier to see. So here is the result. The second part. So the second part. Wait. So which one you want? You want the smaller first. Yeah, smaller first. Okay. So you want the smaller than in front. So 1A, 2B, 3, but you do need to add extra there. So I mean, there's a lot of things, we just blindly trying because it's faster. And then if you look up the documentation, okay, let's see -1. What does it do? Okay, so something that third argument should be a positive integer. Oh, positive integer. Okay. Increment the start and end position of the spacing between rifle elements given in 1 cannot be satisfied for the input list of length 3. I don't know. You have to look up the documentation for rifle again. Tab H. Yeah, right. So we are basically thinking of how to solve this this kind of trivial problem, this problem, this pain in the ass. Two lists, one is more than the other. You want to just reverse it. So minus truncate, minus difference union intersection. No, you want keep the order, and you just want drop. Okay, you just so take the difference. So you need to know which one is smaller, and you also need to know that number, that length of that. Is there a better way? So is there a better way? Is there a better way? So we have, this still haven't done. Once we do this, then we still have to go back to the pattern matching approach, because that's kind of beautiful. But even that, anyway, even that with pattern matching, our code is getting long, so you need another 1 hour to to shrink it, to refactor. But anyway, so we are using so right now just functional approach. Okay, functional approach. Now we are kind of stuck on this thing. So you need know which one is smaller, and you need the length. And you need to reverse somewhere. Okay, so reverse somewhere. So you need to reverse somewhere. Yeah, fuck. Okay, so I cannot believe this sort by. So if you use rifle is almost done. Rifle and something about pair, okay? Something about pairing. Fold pair. No, fold pair list. No. So what is fold pair? Fold pair is last element of fold pair list, okay? It's like reduce, but somehow different. Okay, anyway, that's not what we want. Paired bar chart, pairwise list plot. Okay, so we need some kind of pairing to. God, it's just, the. Do we have like anything truncate distribution, truncate sum, truncated polyhedron? Rifle is the one we want actually, but rifle, but you need to read the documentation thoroughly to understand what's going on. So rifle list x equals to equivalent to, so rifle x is ex, e2x, e3x, okay? So that means, so when you give a list, I mean I max n, I mean I max n. So type use intake is of the type use intake. What? Yeah, you have to understand this. Yield a list in which x appears if possible at position I mean plus n. Right, every nth item. So, but no, I don't think, maybe iPhone cannot do it because it's inserting into, it's inserting between elements, not so partition. So partition takes, so pad, we don't want to pad, it's inefficient. It's just you need to know the smaller one, and you need to truncate. So you need to know the smaller of the one list of rows. So that you can do by, you can always do it manually by just get length. Yeah, let's do it manually. So something, okay, something like something, okay, not d that, okay. Okay, so you can always just do that. So and let's not you can do that, okay? That give you the length of the two. Then yeah, but if you do that, then you need a module. So Let's stop with functional. Let's now. With is the most better form because it defines constants. So if you really have to use a temporary variable, I prefer to use with, because once with takes two arguments. The first block is a list of variables. You must have a value for it. Okay, so they are constants. You cannot change once you assign it. Then the second element to with is expression, whatever you want to compute. So I prefer that. But for our problem, you kind of like, if you want to use with, then you gotta have nested with, because then you want another variable. Or if you want to do something like that, with doesn't allow you to assign parallel assignment called destructure assignment. So you use module instead. So there's this thing module, which is like Lisp's let. Okay, module is like Lisp's let. Here's variables and here's the expression. Okay, but I don't want to use that because because in Wolfram language that means every variable name will get term rewritten by a new temporary unique name internally. That's because Wolfram language, the engine, the way it works is by pattern matching. So unique name is all critical. So, but this module, we are talking about few microseconds, but so anyway, so what should we do with, with using with gets a bit complicated because you can not modify it. So, but if you do not want to, cannot allow modification of variables, then you got into nested list, then you got into you got like 3 or 4 nested list, nested with. But if you allow variable, if you allow variable mutation, you just use that. But I don't really want to, because what's the point? Just use C or Python. Actually, I'm just too extreme. That it's not really, because module is really quite often used. So wait, this simple problem, I'm running, this is not good. So I need another break. Okay, so let's, my back need another break. Where is the let's see. Where is that rock? Let's do this. There it is. What the fuck? You need to modify that. Yeah, fuck. Oh yeah, we can, open last closed. Everything is temp saved. So insert date. ISO date full time. Okay, so let's see. 2025. Okay. Yeah, need a break. let's get back to work. Okay, need to finish this. Okay, let's see. Let's remove that and see how many people are watching. 5 concurrent viewers. Okay, so yeah, let's fuck with width. Let's just use module. Let's just get thing done. Okay, let's just get the thing done. Modify variables. Okay. Fuck it. So width, so take drop, and this sort by that can tell us which one is. Yeah, we don't need that. So length, we can actually do that, and then you just declare variables there. You know, just declare the fuck bunch of variables. Forget about, you know, elegance and all that. And smaller length we can also get. Let's put there for now. And here remove the width. Oh god, the nested width. Let's put there whatever that is, and new list equals to, so this is the final test. This is what we need. Final test. You guys can see me? Everything good? Okay, so this width read up. So now we just function, and we just have module. Okay, you can see this is a module. So module takes 2 arguments. The first argument is a list of variables like the list let, and the second argument is whatever you want to do. So so we have lots of variables. So god, so let's meanwhile make them better. Better variable names. So you kind of let's not do this. Okay, let's do one thing at a time so it's simpler. And let's use compound expression, and let's rest length equals to that. Okay, it's, you know, forget about fancy things. Okay, so you got the front list length and this length, and then you need to forget about that. Then you need to know which one is smaller. So let's abuse. Let's just use if statement. So if x front length, the front length is greater than let's say if it's smaller or equals to the rest length. Okay, rest length, then what we do, then oh god, you need to reverse them. Fuck. If the front list is less than the rest, then use the front. Okay, so you basically just, so is that fine, you don't want that. You do want that. So if okay, so wait, so what if the front is smaller or equals to, then you reverse the front. Okay, then you just reverse the front. Okay, forget about take new front. So here you need the new width. New local variables. Okay, okay, you declare 2 local constants. Okay, so if it is you know, so if front is less or equals to rest, then you reverse the front, new front, and and then you take the rest by what length? By front length, okay? Yeah, you drop it, you take the first, yeah, so yeah. So once you have this, now it's so simple. Now, but okay, so but now what if they are not? Then you do a width again. You do kind of a width. If they are not, then you do this. But now you, so in this case the rest is smaller, so you have to, okay, so reverse something like that, okay? So reverse x rest, okay? Then here you take x front, x front, not length, x front, just front, by the rest length, okay? So yeah, new front, new rest, then something. Then what is that something? The something is going to be, do we still have that somewhere? No, good. So basically, then you just do this, okay? You know, fucking so easy. Just, you know, whether it's true or not. If it's true, that means this matrix has a horizontal mirror line, okay? So new front, x new front equals to x new rest, yeah. Same thing here, okay? Same thing expression here, okay? That kind of like, that's it. Oh god, this is too much, you know. I'm now not in, no, I'm just in like pushing mod, so you're missing a comma there. So clean, so you know, too bad my Wolfram mod. I'm using Wolfram mod that allows you to code Wolfram language in Emacs. But one feature missing is that it doesn't have formatting of code. So, so by the way, you can get it for free. You know, go to this website, just search for Wolfram mod. It's on GitHub. So it allows you to code Wolfram language in Emacs. Why? Because Emacs you can more efficiently operate. Well, because software keys, you know. But I can, you know, I will be down the road make Wolfram language also use software keys. You can program the keys, by the way. You can program the notebook. So the notebook is just like org mod. You can, and you can also program keys, so it will behave like software keys. But I haven't done that. So right now, this missing feature is that you cannot indent it. So wait. So for example, it's very, so once you have long code, it become you know, unreadable. So for example, if you paste this in Wolfram language notebook, then it auto, you know, it becomes that beautiful thing. So actually copy that, copy, and paste it back, you know, that's that code. So let's delete that shit. Okay, so we need, you know, so I need to code this. It can be done, but I, you know, I don't know how yet. So that Wolfram mod can just press a key and it format like that. Okay, so we got this. So what? So we need to make sure this actually works. So we need to double check the logic. So this part we don't need. If same index list, no horizontal okay, so this we don't need. This, if this return true, means the matrix has a horizontal mirror line, else no. Okay, that's what this is doing. And okay, so now it uses map, but actually you need to, as soon as it's valid, you want to stop. So so you want to use scan instead. Okay, scan, and then here it just say if this is true. When this is true, return. Okay, so wait. Yeah, so if, so you need to add if. Okay, if that returns true, you need to say return. Okay, return true. Okay, that's how Wolfram language is. Otherwise do nothing. Okay, otherwise just return false. Okay, so yeah, so this gets, this formatting is a bit so we need to copy this expression. Wait, you copied it wrong. This nesting problem, this like Lisp, you got this nesting problem. You gotta be careful. Okay, so there. Yeah, so there. So you can copy that, paste it here. It format automatically. Copy it, paste. So this is our new formatted code. It's so anyway, so this delete. So make sure this is right. So font. First of all, you get the font. Yeah, let's just run it. I got pretty tired now. So let's just run the whole thing, see if it works, return true or not. And right now this only works on the first matrix, so only works on this one. So the expected answer is false because it's not horizontally symmetric. Shit. Returns that. Why is that? Fuck. I don't know. So this, why is it not returning anything? What is it? Why is it not returning anything? What the fuck? Come on, scan. Yeah, scan is like map this function to that. God, fuck. Why is that? Let's say map. Okay, so false, that's expected. But if you change the matrix to 2, it'll return true. Okay, 2 means this one. This one's got a horizontal mirror line. Okay, let's run it. Yeah, false my ass. Okay, I not good. Fuck. So this advent of code, you really gotta be careful, especially when it becomes day 13 or something. It gets more difficult, and then if you are trying to avoid procedural coding, it's more difficult. So I was already prepared. I kind of think about that because last day I didn't complete, but then still now it's like 4 hours. It's like 5 hours. It's not working. We have to debug. I don't know what's going on. Fuck. So if that is true, then return this. So why is it? So is the front less the end or what? So in the first case, the front is 1, 2, 3, 3 rows. The rest is 1, 2, 3, 4, 4. So the front is indeed less than rest length. Okay. Now, did we get the length right? So front end length equals to that, length rest length equals to that. That seems right. So variable front length, rest length, and then drop matrix front. Oh fuck! I forgot another thing. Module does not take chain assignment. Fuck. So if you go back to my tutorial, you can see scan. So let's go to the variable section. The variable section, global variable, local variable. So here is how you define local variables. Warning, when the body is more than one expression, add semicolon between them. Okay, that's not it. Warning, the latter variable's value expression do not know the previous variable's value. So you cannot wait, but we didn't do that. We actually, so actually we declared them as variables and we did assignment here. So why is that wrong? So front end, front length, rest length. If front length is smaller than the rest, then you reverse front. New front equals to reverse front. New rest equals to take rest and take the first end. Let's just say that. Okay. Let's forget the if. So okay, so new front, new rest. You don't need the width. Okay, so fuck the reverse. Reduce variables. Okay, then you don't need the width. So similar here. Okay, so this needs to go out. So take front rest length, new front. Okay, new front, new rest. Okay, delete that. Okay, so now it's simpler. If front length is smaller than rest length, then reverse front equals to then you map the whole thing. Let's say map, not scan. Okay. But it's still wrong. It's still wrong, my friend. You are wrong. You are just wrong. No, you. False. Now the second matrix. Please let it be true. Please, did we? What? Go down. Now, okay, why is it false? What exactly is the matrix, second one? So let's see. Oh, God. So matrix form. Okay, so this got symmetric. It's symmetric. Why are you saying it's false? What the fuck with this with you? So so let's print. Let's just print. Debug. Let's do it here. So print. God. Print is a side effect, okay? Font length. Let's see if at least it do that correctly, okay? Let's do that. Font length 3, rest length 4. That's right. And let's print font. Okay, then you want to print font. Font is font. Front is that, rest is that. So what? Well, because this is matrix 1. Matrix 1 is always not. It's not. It doesn't have a horizontal mirror line. Okay. So let's say 2. So let's show me exactly what the fuck is going on. Run it. So so this thing. Yeah, they put this, so how to see. Oh God. So let's copy that, do that. Matrix form, okay? So that's one part. So the rest is this thing, copy, paste, matrix form, okay? Now compare. What fuck is going on? So compare, let's go all the way. So we are doing the second matrix, which is this one. Let's see what is our front and end. So this one, the front is got 1 2 3 4, and the rest is got 1 2 3. Okay, so the front is got 1 2 3 4 items. The rest is 1 2 3. So the rest is smaller. So the rest will be reversed. And oh wait, then the front needs to, you need to drop the top, not drop the last. Okay. So our logic is wrong. So here, when the front is greater than the rest, then you need to not take, you need to like drop the difference, okay? Or you need to take from the end, okay? So it can take a negative integer, that means take from the end, okay? Yeah, so let's try that. It should return true, it better. False, what the fuck? So let's do this again. Matrix form. Matrix form, okay. Yeah, that's what we want. We want to apply a matrix form so it's easier to read, okay? So copy that, paste, do it again. So now we see, now let's see, make a backup, go to the top. Now we want to focus on this part. So front is 3 items, that's correct. Wait. You dropped what? No, wait. Okay, now it's all confused, okay? Wait, this is before we drop. So actually, so our print function is wrong. This is the before. Okay, so we actually want to do them. Yeah, we want to print the new font and new rest. Okay. God, so now you have to. Oh God. Now you need to have a variable again, width again. Do I make sense? Is it? Do I make sense? Okay. Yeah. So, God. So you need to. Yeah. Why don't we just write it? Fuck it. Fuck. Okay, so this is a new font and new rest. Okay, so God, you're gonna be really careful here. You don't wanna fuck around. Okay, this is emergency. I mean, this is not emergency. What's the proper name? This is like pressed coding. Okay, so like you gotta death match. Like you just have to continue until you drop dead. This is the pain. So width actually, so this expression needs to go to inside there. Yeah, there. So well, okay, so let's do that. So this is an if statement. Okay, so need to turn this into a width statement. Cut. Okay, so okay, comma that. So new font. God. Just copy here. So right now, copy. Okay, go. So copy, go. Not that. Wait, and define that new rest equals to that. Okay, now think about the logic. Don't fuck up. Now think about logic. Okay, so new font. So then you need to print. Fuck. So new font, new rest. Okay, so you need to print it. Do you want to print it? Yeah. Okay, print it. So print it. So X font. This is new font. So X new font. Okay, X new font. Okay, now this is X new rest. Okay, copy that rest. Okay, matrix font. Copy that, and we do the same thing here. Copy that. Okay. Okay, now let's think about logic before we try it. So I know something is wrong there. Kind of tell. Wait, I don't know actually. So if the font is smaller, let's look at when the font is larger case, because that's what happens with the second matrix. So when font is larger than the rest, okay, so you want to take when font is larger. Let's always reverse the font. Okay, let's don't do nothing with the wait, let's just figure out where's the bug. You need to drop. Okay, so you yeah, so instead of take from the right side, let's say take 2. Rest then, rest is smaller. Okay, wait, so if the rest is larger, you want to drop the first. Okay, so you want to, let's see what exactly. Always reverse the font. So always reverse the font. Let's do that. But you want to drop the first. Okay, so take, yeah, so you want to take gives the last n element, right? So what's wrong here? There's nothing wrong. Take that number of elements, that's right. Then new rest is reverse rest. That should work. Okay, now I don't know what logic is, it should work as far as I know. So let's kind of compact this, this is getting long. So let's Wolfram language formatted, please. What? Press this button. What does this button do? Yeah, this button. Copy. Let's see if we get prettier somewhat. Oh, they use the map. They change it to the map function syntax. You see. They converted. Before. We are using map. Okay, so let's go with his. Let's go with his. The Wolfram suggested. I don't know. So let's run it. Let's see. Run it. Let's just run it. Let's see. Okay, new font and new back. Let's see. So remember, we are dealing with the second matrix. Is that right? Second, yes, that's right there. And so the second matrix, the front is 1, 2, 3, 4, 4 items. No, you got 3 items. So what? What? So we got it wrong even earlier. What the fuck? Wait, there's something. We got the bugs. We got bugs, man. What is this index? And what is the same index list? Did we? That's incorrect. Fuck it. Same index list is not 3. It should be, let's say 1, 2, 3, 3 and 1, 2, 3, 4. It should be a list of 3 and 4. Oh God. So did we forget same index list? Not 3, man. Did we? Oh, because this only does 1. This only does to matrix 1. Ah, God. So that's like a programming typo. You know, we got tired. There's no logical error. It's just that we forgot. You know, because when we did this, we were just testing the matrix 1. We are not, you know, mapping the whole. So that's just for matrix 1. Yeah. Fuck. Oh God. You know, I'm kind of tired. I want to go. What is this? 9 people concurrent viewers. So far we've been coding almost 6 hours. 6 hours. But right now, in the past hour or two, we are like in a death march mod. So we got a, you know, we got an obvious bug. You know, I'm tired. Well, the issue is that this same index list is it's a list of, yeah. So if you want to fix that, you need to change this to matrix 2, since we are doing the matrix 2 here. You know, all this debugging turns out, yeah, because our input is fucking wrong, because we are computing matrix list 1. Can you quickly fix it? Like just hack it, just say 2. Yeah, we can actually. So do it that, and what is the result? You should say 4. You see, and now if we go back here, do this true. What the fuck? So it tells us now code is correct. It says the second matrix, this one, has a horizontal mirror line. Okay, so what we do now, all we have to do is just map so that it applies to all matrices. Then actually true or false is not the answer, because you need to know which line is that. You know, you need to know this index number. Actually, we have it here, x index. Okay, wait, not that. You know, this number 4 and 3 for each matrix. Then you need to like sum them up and fucking count and sum them up. This advent of code day 13. So and another 5 minutes break maybe. So it's well, I mean, overall still good exercise, because I haven't been in a painful coding situation for a while. Because when you work at the day job, that happens. You know, you need to, you know, just get something done, because you know you delayed, and at the end you have to get it done. So right now it's clear with a simple functional approach. Okay, so now how many lines is that so far? You know, this bunch of shit. Well, I mean, most of it is print statement. I mean, half of it is print statement, but that's but basically this is a solution. So all we have to do now is just fix a little bit things like map. Then we need to do transpose to check the vertical mirror lines. Then find out the number. That's easy, but that'll take another 20 minutes. I mean, it's easy in principle, but you always end up with a bunch of shit. So let me think about what to do. I think another break. And after 6 hours, now I'm hungry. And my hand here is hurting. and kind of hot. Is the fan even on? And back sitting on this chair for like 5 hours, it's no good. Oh god, actual shit going on. But no result. Can I tolerate a fucking live stream video of 6 hours and no result? Oh, but I mean, this actually, should work, but, all we have to do is just something a little, but no actual answer. No. So we have to finish this. Okay, finish it then. Break. Okay, let me go break. Let's go to the break page. Where's the break page? Let's see. Open. What? Wait. We already have the break page. There. So you just need to update the timestamp to another break. ISO datetime 4. Remove that crap. We will return by 6:10. Okay. And the current state of things you can see on my website. Actually, I need to update it. So let's update it. Okay. So go back to the code. Not this one. What is this one? This is the talk show. Open the code. So which one of these do you want to show people? Let's see. Almost done. Okay, so God, this one is returned by Wolfram, and that one is returned by, that's our code. I want to use our code because we're gonna change this to scan instead of function. Instead of map later for more efficiency. Because once you found that the matrix has a horizontal mirror line, you stop. You don't check next pair of same adjacent rows. Okay, so we're gonna change this to scan later. So, but now here's kind of state of code. Basically almost done. Okay, syntax correct. Make a backup showing browser. That's today's algorithm description and exploration and edge situations of the problem available code. Then here's our code. Yeah, so even with this code, it's gonna be 300 lines, right? But it can be much reduced. It's just a matter. Okay, so break. Okay, this time longer break. Okay, 8:15. So together I've been taking 30 minutes break already, I think. Okay, but hold on a second. Let me upload to my stuff. Oh, shit. Actually, I should do this every day, so it will be, because the more you do, the more you get familiar with the live stream situation. You see, part of this, of course, you also learn, Wolfram coding, you become more fluent. So can you name a function in Chinese in what? Oh, in Wolfram language? In what? In Wolfram Mathematica? Oh, German Molina. Yes, you can. Okay, let me show that. Okay, so let's say function, let's say variable, okay, x equals to 5, let's say not x, okay, but x is some Chinese, right? No, so let's switch to Windows Chinese input I, okay, so that character is love. So now switch back to my keyboard, so shift enter 5, okay, now you copy that character, copy, paste there, return 5, okay, so you can, oh shit, I forgot to show screen. Shit. So can you see, I already typed it, so here's Chinese character. We can try another one. Let's try another one, okay? So switch to Chinese keyboard in Windows. Let's say Su, okay? That means number 6, that means tree. I wish to see a tree or running water. Let's say tree equals to 6. Shift enter, okay? Now Control L to get last input. Delete that. Now just evaluate that. That's a Chinese character for tree. Shift enter. There it is. Okay. Now let's be back. Now I gotta be back at 8:20. Okay. 10 minutes break. God, so much. What are we doing here? So can you guys see? Yeah. So show that and show that something. Okay. And okay, something. Oh my god, what a session. What a session. I need more break. 6:14, so 6 minutes supposedly. Finished 3 cups of drinks, apple juice. Now let's change my chair. Now this ergonomic chair. Okay, I'm gonna lift the chair. 1, 2. That's not good for your back. Yeah, gotta finish this fucking problem. Oh god. Okay. And do I want to finish it? Yes. Must finish. Okay, let's just start. I'm back early. Let's just code. Okay. Let's code it so that we actually have the whole thing. The whole thing is gonna be one line. Matrix list equals to, so that's the matrix. Yeah, matrices. That's a bunch of matrix. Okay, matrix list. Yeah. Am I back? Voice check, video check, audio check. So matrix list is a list of these blocks. Okay, and then matrix list and what? Okay, so one of them looks like that. That's the first one. Then the same index. This needs to be. Okay, so this needs to be a map again. This, yeah, I'm gonna show you because right now we are only doing to this matrix. Okay, so copy this code. I'm gonna modify it here so you can see a copy what it looks like. Map a function. Okay, function, and this one variable yy. Okay, yy something, and you want to map to. So wait, so this is the, this is yeah, okay, so this part needs to be yy. Okay, and the whole thing is cut. That's this yy will be. Okay, that's the body of the function. And what you want to map it to? You want to map to the matrix list. That's right, you don't need that. Okay, so now this will give you basically 3 and 4. 3 is a row that the starting row number of the adjacent same row, okay, for the first matrix, and 4 is the starting row number of the adjacent same row, 1, 2, 3, 4 for the second matrix. So this here, so this will return that. Okay, and we don't need wait. Actually it returns these. Okay, because now you are mapping, so potentially more than one item. Okay, we can try. Yeah, but this comment now is incorrect, except if we do. Wait. Oh god, fuck. Yeah, so okay, so anyway, so we can try it, and so you can see how it works out. Run it. So you see, where is the result? Okay, so you need to show the result. X, okay, turn off Chinese, back to English. X same index list. Okay, you see, as I expected. Okay, so that so God, we need to get this to work. Okay, let's not that. Let's ignore that. Okay, let's not do that. Actually, the proper way is to say. Okay, so then. Okay, then you got the list. Each of these elements is a list of the row. Same row index, and the next element is for the next matrix. Okay, because we have quite a few. So the possible results, is like that. Okay, so let's ignore the comments. Now let's do this quickly. And now you need to turn this function into map. So you need another map. Okay, so let's remove the debug, shall we? Fuck. So copy. Let's just, for backup purposes, let's put it here in case we want the code back. Now go back here. Let's remove the print. Okay, so in Emacs we can list or print. Yeah, God, I hate that. List or print function. So delete or print. That print lines. Okay, just fucking delete them. So now it's much simpler. So and you are using map. You need to turn that into scan, and then. Then you need to check the vertical line. You need to do transpose. So there's a lot to do. So same index list. So you cannot, you cannot just do that. God, this is so much pain. I'm suffering. So in this jumbo code, now it's becoming a jumbo code. Not really, but I mean, actually this is normal-ish Wolfram language code. But now you need to map to that. So this function, so this used to be just one. So you need to map again. So you need to map. Okay, so let's just write down. Okay. Map a function, let's say okay, that's a variable, I mean the argument, and here what do you want to map to? You want to map to the xsam index list. Okay, then the will be will be this thing. Okay, this will be here, so give a unique variable. You can see. So this is the body. Okay, cut. So put that there. Can you see? Now that's how fancy we become. Still pretty simple. Okay. And the inner function is not map. It just should be scan. Yeah, but fuck it. Okay, so this will return. What will this return? I can tell you. It'll return false true in a nested list, meaning that the first matrix do not have horizontal mirror lines. The second does. Okay, so we can try it. Yes, we can. Yeah, copy that. Go back to Wolfram language, paste it, do it. There, exactly. Okay, now you just fucking, you need a column number. Jesus. you need the column number for the problem because it wants a column number. So okay, so instead of returning true false, okay, return the column number. Okay, that's easy. Okay, so wait, so hold on a second, let's just be steady. So this map, you want to return the column number. Okay, so can you return 0? Yeah, you can return 0 if you want. But the point is, as soon as you find, now is it possible, fuck, another possibility. Is it possible, given the matrix, such that there are two mirror lines? Yes. Fuck the advent of code. So there's another special case where we document the special case here. Crazy situations. Okay, let's document advent of code. Where is it? Not here. Here, crazy situations. Okay, what if there are more than one mirror, more than one horizontal mirror lines, or more than one vertical? That's a valid situation. It's possible to have more than one mirror. Wait, is it possible actually? So wait, so yeah, it is possible. For example, let's show an example. Show them example. Okay, fuck the break times. Okay, so is it possible for the mirror lines to be yeah. So in this example, here is a mirror line. Okay, here's a mirror line. Fucking advent of code. Here's a mirror line. Okay, so it's possible to have multiple mirror lines. Jesus. But the problem description, does it say what to do in that situation? I mean, it's not about whether does it say. I mean, does it affect the final answer? Did he word it so that when you have this situation, it's unambiguous? Did he? That's the question. So when you have this situation, or maybe this situation never happened. If this situation never happens, but then you think extra, you are wasting time because they don't care. Those who didn't think of this situation, they benefit. In other words, those people who are inferior in coding skills, they win. You see, so if the user example does not contain this situation, then it's just bad problem. It's a bad puzzle. But anyway, did he say exactly what happens when you have this situation? Okay, so make sure we are correct. So there's one mirror line here. there is one mirror line here. Yeah, is that right? Yes, obviously correct. Yeah, I mean, it's true. There is one mirror line here because, you know, so did he say that you have to start from beginning or something? Let's check. Let's just, I'm too tired now. This pattern reflects across the horizontal lines between row 4 and 5. What? Yeah, okay. That's a simple, unique example. So to summarize your pattern nodes, add up the number of columns to the left of each vertical line of reflection. To that, okay, so it actually starts with vertical lines. Then for the horizontal, you have to add, you have to multiply by 100, then add them. Okay, so for us, we have to multiply by 100. So for example, in this, anyway, so in this, some cases, okay, let's say 3, 2, let's make this more clear. So that's one example, okay. Now another example is that, let's say, well, in this example, you also have 2 mirror lines. So actually, I think you want to maximize. So when this, I mean, and I don't know if he says that in a specification, but ideally, when there are multiple mirror lines, you want to find one that closest to the center. Therefore, you get the maximal line numbers. I suppose that's the situation. But did he say that? I'm fucking annoying. Any input? Hello, George. George, I've been coding for 6 hours, so I'm kind of too tired. Hey, thank you. Thanks for Starfly Keys. I'm getting used to it, and so far I love it. Thank you. Damn try. George says, you are overthinking it. You just need to make it work. Yeah, that's true. No, but I mean, not exactly, you just need to make it work for the input and output you provide. Yeah, that is a problem. But however, does the user input, the example input doesn't contain situation like that, right? But does the user input contain situation like that? You don't know. Each person have a different input. So the situation is that if I'm 100% analytical, I thought of this problem. This is a problem because when you have this situation, it's ambiguity. Your problem is not well specified. You have several different possible answers. That's right. So if this pattern does not occur in the input, first of all, he doesn't say what you have to do when this situation occurs. So if it does not occur in his input, in everyone's input, that means it's a lousy problem because the problem punishes those who correctly analyze the problem, which you will encounter in real life. The problem is underspecified, ambiguity. I got the answer, you got the answer, our answers are different, but both are correct according to the specification, underspecified. Okay, so if the problem, all the user input, if it doesn't contain situation like this, like these cases I listed, then it's a lousy puzzle. But if it does contain the situation I listed, it's also a lousy problem because then it doesn't say what you should do in that situation. Does it mean multiple answers are acceptable? So that's right. That's my answer. I mean, that's, I'm correct. So anyway, ranting. So basically we got this. I'm gonna stop. Okay, I'm too bad. We just need a little more work. So yeah, but I'm gonna stop. So I'm kind of really tired. So here's the Wolfram code. It looks like that. It kinds of tell you. Yeah, and also you need to get the column number, not just, column number is here. This is this, yeah, it's this index. Well, except when you have like multiple mirror lines, then you don't know which one it is. So because it's relevant, because right now for efficiency reasons, I need to know as soon as I find a mirror line, should I stop or not, right? Because if the problem specifies by specification there's only single mirror line, then the efficient solution is not to use map. If you use map, it's inefficient because maybe the first line, the first two row is mirror, the rest you can ignore. As soon as you find that, you just ignore. But if you have the case of multiple lines that also refresh, then you do need to continue. But the problem doesn't say which one is, what the fuck the problem. Fuck the advent of code. Okay, that's okay, I think I'm gonna stop. Okay, so here's the Wolfram code. So much 6 hours coding basically. And okay, so that's one part. But also we started to do pattern matching solution, which is so elegant here. So it just, for example, use pattern matching to find if a matrix has horizontal mirror lines. So this will do it. We showed the code before. This will do it. Okay, yeah, because I changed some variable. Yeah, so the matrix is that still a thing. Anyway, so it was running. So the other situation is that just completely use pattern matching, no function, no checking out which length is which row, at all. You just pattern match, it solves the problem. So but we haven't completed that. We all, so anyway, that's it for today. Thank you guys for watching. Okay, bye guys. Oh my god, that's 6 hours coding. What? 6 hours and 30 minutes. Okay, clean up, let's put this back. Color it, show in browser. So that's what we have today. Too bad, so yeah, so next time I gotta be more like knowing the situation. So this cut. Okay, so let's go back to talk show. Let's put this in the talk show page. These are some of the like demonstration of Wolfram language code, simple code, and coding issues. We, some. Okay, color it, show in browser. So it's here for now. Some of the function, Wolfram language function explanation. Okay, that's it for today. And this one is a break. It's also put the break announcement, intermission. In the old days it's called intermission. So text, paste there. Okay, what else? Okay, let's we don't care about that. Message buffer, and delete that. This error message. Okay, that's it. Bye guys.